الحمد لله رب العالمين والصلاة والسلام على أشرف الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. Dear official delegations, dear audience, esteemed guests, we are delighted to start our third and final day with this session titled Health and Air Quality Dust Affected Region. This session will be chaired by Dr. Ali Dosri, so I'd like to invite Dr. Ali Dosri to the stage to invite the panelists.
Bismillah ar-Rahman ar-Rahim. We're opening this session, the first session for the third day. Hopefully you enjoy it, all of us. I'm calling Dr. Salim Francesco Bocconari and Christos Fantikokis and Muhammad Abu Al-Laban, Professor Turki Muhammad Habibullah, or Dr. Zainab Abdullah to be joining us in the stage, please, to begin, inshallah. From Kuwait Institute for Scientific Research, I'm Dr. Ali Dosri. I'm happy to join this marvelous meeting and conference. It fits exactly to the main desert environment and all the globe regarding the dust. But before we begin, in fact, regarding the dust, we need to put some elements and key points in order to understand the dust. Understanding the dust is the most important thing before implementing any fixation method or adaptation method. I would use adaptation method better than this. Here the dust in the Middle East and properties and adaptation methods we'll discuss it in general. And to understand the dust, you need to go to the field. You need to touch the dust and you need to feel it and go to the hot spots, the source areas of the dust, analyze it. Study it in details, the pollen in the dust, the radionuclides in the dust, the mineralogy, the particle size, and so on. So, next slide, please. Okay. So here the challenges, the major things we passed through it. Part of it is the challenges and solution for the dust and sandstorms. Challenges and solutions for the mobile sand and dust disappear. Usually there's different terminology: sand storm and dust storm and sand and dust storms. I would believe in the last, which is the sand and dust storms. We never face a sand storm or a dust storm by itself. Usually it's mixed with each other. And I show you part of the elements. In fact, you see some images that adhering particles are in the top of larger particles, like a bus station. Go to another bus station, which is when the particles hit each other, the splash of the particles, and so go to another particles. So that was why that visibility causing, in fact, a major problem and causing a huge health aspects and economical challenges. The other thing, Next slide, please. Yeah. This is what, the type of suspension. For example, the rolling. There is a long-term suspension, and depending on the size, which is less than 20 micrometer. While there is a short term, which is between 20 to 70 micrometer. And there is a saltation with the dust storm, which is usually within a 2 meter size, 2 meter height, and the creep with the sand dunes and so on. So if you go, for example, if you go to, we find after collecting multiple sediments or dust samples all over the world. I'm a dust collector all over the world. We found there is a zonation characteristics. There is a fingerprint regarding the dust. Each location of the dust, you can give me any dust in the world, I can tell you where it comes from. According to the origin, we see there's different zone as seen here. The Australian desert, for example, it contains low carbonates, high in iron content. But while in Arabia, for example, in the southern Arabia, contains much higher quartz and feldspar, while in the north, in Iraq and northern Kuwait and northern Saudi Arabia, we found, in fact, carbonates is there, maximum, more than the quartz. So if we see here, for example, the amount of dust, in fact, all over the world is so variable. And in fact, much with the Middle East are containing the much deposition of dust. Only the southern Sahara is much more. But we found some, for example, here in the Arrow, you see that Dead Sea, for example, in Palestine, and Khurz-Bair in Iraq, and Qasr in Iraq, and Kuwait. It's the variation. Whenever we go to the south, it became more dusty. Other thing is verifying the particle size is important. We found in the empty quarter, coarser size fraction, while in the upper side, a finer size fraction. Gobi Desert, for example, and Taklamakan Desert is different. By the way, the dust storm initiated from Taklamakan Desert in China is so different than Gobi Desert. Sorry. So we find the variation in particle size is huge. If you go to, for example, one of the major things, nobody studied it, in fact, very little people study the behavior of the dust storm, the size of the dust storm. It comes with different shapes. So we make a scale, and we publish it many papers regarding this. Here, the extensive agglomerated dense dust storms. And there is also the extensive Hawk single head dust storm. By the way, this is in the Gulf, Arabian Gulf region. We found a single dust storm that initiated, in fact, in the early stages, but now it became 3 heads, and which is the second row. You see the 3 heads. We saw, in fact, 3 heads become the intensity of the dust storm increase with time. But we noticed that even the dust storms, some areas, low dust storms, number of dust storms we have. Also, there is arrow shape. The last one at the corner, we found, in fact, a trajectory of dust storms initiated from 2 areas in Iraq. We are in Kuwait Institute of Scientific Research, trying to make adaptation method to fix it, because it's affecting about 40 million people. The economy, in fact, is affected. The health aspects is there, in fact, affected. Sorry, but this is, in fact, a major thing in stabilizing these 2 areas is a major threat, because the aviation is being shut down, the airports, many other aspects. The huge cost for the hospitals, in fact, after 5 days from the dust storm. You notice that 2023, there is no dust storms from these areas. This is a real success story, in fact. We're trying to help the people to help themselves as possible as we can. We found about 40 million people in Ahwaz region, in southern Iraq, in Kuwait, in Al-Hassa, and eastern coast of Saudi Arabia, Qatar, Bahrain, and Emirates, and part of Oman. We see here, for example, the dust storms in Kuwait. These are the particles, by the way. The particles by SCM, you saw it here in the down image, you found it from empty quarter. It contains larger particles of quartz, and on top of it, adhering particles, which can join like a small, tiny particles. The other one is from Bobian Island. Bobian Island in Kuwait contains, it's a carbonates, it contains a huge amount of tiny particles also, but it's two different mineralogy. And if the variation between Kuwait, Bahrain, and Doha and Abu Dhabi, Kuwait is the highest dust storms, although it's decreasing with time. Here, for example, the northern Middle East and the southern Middle East, regarding the particle size and mineralogy. And there is a huge difference here, in fact. The southern, it contains the sand for 40%, and 97% mentioned in the eastern empty quarter. 97% mostly is sand. It's very fine sand. And the silt, the major component, very coarse silt, is the major component. While in the north, it's became, even though the mud content is here showing up 74 or something, but you notice that the mineralogy is so variant compared to the quartz is the dominance within the southern in the empty quarter. Here, for example, the jets that comes from Iraq, and the northwesterly wind is the dominance. And we notice that this area, if you stabilize it, it will save the whole coast of Arabian Gulf from different, from the east or from west, and the north also. And this is real, what we are talking to help the people. Most of the research done sometimes for research for development of monitoring, but very little going to the tackling regarding the adaptation methods. And that's what we want to help the community as possible as we can. The project began 2 years ago, and we are one of the areas completely stabilized naturally by native plants. The other area is now under stabilization by two techniques. The first technique is by biological fixation by native plants. That means native plants needs no water, needs only rainwater. That's it. You plant it, that's it, and it will go by itself, which is haloxanol, one of the and Tamarix afella. And we are in progress in this matter. Here, for example, as I mentioned, any calamity in the terrestrial environment, like land degradation, desertification, and so on, it's a benefit for the marine environment. I discussed this with many marine geologists, marine biologists also. They mentioned it's very good for the marine environment because it contains iron. Iron is the first feed for the phytoplanktons and cyanobacteria and so on. And that's why we find the variation by the iron. In the southern Kuwait, for example, it contains a fish different than the north. There's a common name fish called zubaydi in Kuwait. It's so different than the zubaydi in different areas because of the sediments. So the dust plays a major role even in the palatability of that fish from different region to another. Sorry. Next slide. Next slide, please. Anyway, we see also in the images, the precipitation, and also here the precipitation of two different years. So the precipitation is different from one year to another. Also, the precipitation in 2020 is so different than 2019. The dust fallout is the last one. In fact, the dust fallout in Kuwait is varying from one place to another. Yes, this is a Calypso images, which the dust during a dust storm comes to Kuwait and to the Arabia and to Al-Hassa, and a huge difference from the two jets in Kuwait. You find a huge amount of dust coming during the time we mentioned here. Here, for example, the silica from different stages, we take it all over Kuwait, we find the variation was different. So the type, even affecting the marine environment, affecting the terrestrial environment in this matter. Here, for example, the organic matter. By the way, after analyzing the sand traps and dust traps, we found about 4.8% within the sand of the weight of the sample is containing organic matter, while the dust about 9% of its organic matter. So it's varying from one place to another. It's a good feed for the either in the marine environment and many other aspects. Here, for example, we found even variation regarding the cyanobacteria growth, which comes within the dust storms. We find cyanobacteria became very high, so consume the oxygen, make a dead fish kill. We call it a fish kill. And the expansion of this during the dust storms in summertime. And this because of the iron content contained, is a good feed for the marine environment. One of strategies to make like a drones to make the water current in the down to make drones, but very well understood that can make the water currents become very well. That oxygen depletion will be far away. This is one of the strategies. It's a crazy idea, but it will be applied in future. Other thing is regarding the amount of dust. The amount of dust in the sea bodies. We find Atlantic Ocean, Mediterranean, and the Arabian Sea, and Red Sea, and the Arabian Gulf. The Arabian Gulf is the hugest, about 10,330 tons per kilometers cube, and this is a huge amount, cube of water. For example, here the dust storms became lower with time, due to the adaptation methods and many aspects. But the dust in general, haze and suspended dust and rising dust is increasing a little bit. But it became lower in Kuwait and some other parts of the area. In Al-Hasab and in Emirates and Qatar became lower. Usually Qatar have half of the dust storms compared to Kuwait. So, same as Emirates. Here, for example, the change of vegetation. One of the land degradation problem here, because of change of vegetation from 1977 until 2000, for example, we find the variation in native plants from plants that are capable to catch the sand and dust to plants less efficient in catching the sand or trapping the sand and dust. And that makes a huge problem in the future. So we need to make what we call al-hima. Al-hima is part of not to allow the grazing, but in a certain time, not the preserved areas, open areas. Anyway, here's the dominant native plants in Kuwait and the area, which is Cyprus conglomeratus, Halicinum salicornicum, Rhanterium ibosum, Astragalus spinosus, Lasium shawi, Chryseis cocolith, and Panicum trigorum, Caligorum, and Nitraria, Tamarix, and Halicinum, and so on. These are the plants that are capable to catch the sand very well. These plants we usually doing it to Kuwait plantation. We reach about 200,000 plants plantation with school children and make the public awareness and so on. We are continuing every year sending messages for this pair. This is for the lab content. We analyze it in the dust and the sample, some sieves analysis. Sometimes we use what we call it laser granulomerical analyzer, which is the best one. By the way, the dust analyzing this particle size should be by laser granulomerical analyzer, because it needs the counting the particles in according to size fraction. The count is very important regarding it. It's not different than the sand. Here, for example, the mercury content contained here, which is with the dust storms, usually the pollution became low from the mercury and other, because it's absorbed by the dust and settled away from. So measuring the mercury in the air, in fact, usually it comes in summer. It's varying indoor and outdoor. This is one of the things. This is what I call PET surface area. I think one presenter yesterday mentioned about the diversity was a good presentation. So you see that, for example, the source area in Iraq have the highest BET surface area because of the carbonates. The surface of the area contains, in fact, the hugest amount. But when we go to Al Ain in Emirates, it became lower. And we go to Libya, for example, it became lower. The highest in Iraq, and when you go to the south or to the west, it became lower. So each dust has a fingerprint from the surface, from the physical and chemical properties. This is, for example, the radicalized. We identify from it is regarding the anthropogenic sources and also regarding the resuspension. What means resuspension? Means that when the dust deposition, how much is being resuspended again. Most of the dust in Arabia North is resuspended. That means it's deposited and resuspended. What's the importance of this? The importance in that by cultivation, it will lead, we can prevent the resuspension. But it's a real target in the future as a solution adaptation method in the future. If you go here, for example, the off-roads and grazing points, I put the grazing points is in the Sahara, or in the desert. We put for camels and sheep. And the dots represent, in fact, the number of grazing points in the area. The density of these grazing points and the off-roads is related to each other. And you see amount of soil compaction and many other aspects causing the dust in the area. That should be controlled in the future. Anyway, this is the variation with distance. Whenever we go to the South Kuwait, for example, we get more dust, more sand and dust deposition. For example, here, for example, the amount of dust measuring and happens many, and there is a huge cost. In fact, removing the sand, the cost is about 1.47 US dollar per meter cube, and this is a huge amount. In fact, costing Kuwait millions every year. This is, for example, sand dunes formed never before. This is Al Ain, by the road of Al Ain. You see a green belt around the road, the main road. Where is the wind direction? If you see it, and can identify it from the top, the wind direction, because of the death by sand blasting. The sand blasting causing the death of the first line and second line by 64%. Because you need to save the plants to grow up. Otherwise, it will the death. So, as I'm still in contact with the people in Emirates, they still suffer from sand encroachment, even with the green belt, because of the insufficient part of the gaps there regarding this part. Here, the sand dunes, which were initiated within 2 years after the activity, in fact, huge activity, anthropogenic, by the way, in Western Kuwait, northeastern Kuwait, sorry. And we are in analysis with this. This, for example, the amount of cost, for example, costing about 0.34 KD. That's about 1.24 US dollar. And 0.73 compared to 1993 to 2013. It become 1.47. It's a huge one, in fact, cost in the future. What's the effect in the solar energy and wind energy? And the huge, in fact, we measure different things, the humidity and many aspects, and the dust and the solar energy, where do we put it? In fact, we make a very good plan, in fact, where to put the Shagaya area, which is one of the best, to put it in non-affected by dust, the small, and also less affected by dust, and also by the solar radiation is better. This is by the desert in the past, but in fact became very degraded. This is a preserved area in this matter. What we done by measuring the cost of the removal of the sand, we measure the nabka that forms after in the plant. This is an Intraria retosa plant, a native plant, can catch about 21 meter cube of sand and dust. And that's what we've done. In fact, we depend on the native plants. In fact, to stabilize the sand as possible as we can. The other thing, this is the cost and the removal for each plant. We make a cost and how much plant can catch the sand or dust, and how much is safe Kuwait from sand and encroachment and dust, and we find a huge amount, in fact. And we publish it in one of the papers here. Anyway, we see here, for example, the effect on temperature. We found the variation in temperature regarding the temperature and the dust deposition became increasing with time. It doubled every 20 years. And the sand doubled the same, in fact, 20 years. The sand and dust doubling every 20 years in Kuwait. But now it became low. We are, because of the adaptation method. Look to the temperature, for example, increasing by 1.58 every about 15 years. This is good, in fact. But regarding 1971 to 1980, compared to 2008 to 2017, about the precipitation reduced by 42%. Why is that? Because what we call the albedo, in fact, non-vegetation in the land, so the clouds coming, it shifted away from to north. That's why northern Kuwait became more rainy, and the southern compared to the mid of Kuwait. That's what we noticed with time. The other thing here, for example, solar energy, which is one of the we usually found a very good wind direction, wind production in Kuwait, best than solar energy. Solar energy, photovoltaic energy, is because of the dust and the aerosols and many aspects and the rain and clouds, it became not sufficient like the wind energy. So for units, for producing a huge amount of energy, it comes. By the way, here the same this is in Al Ain, that one in China. Also still affecting. I visited China in this matter, and they produce a huge amount of try to cultivate but still they have some sand encroachment problems. What we done in Kuwait to use the cultivation with scientific purposes. This is a V-shape cultivation, dense in the border, more dense. The distance between the branches became closer, while in the middle became far away. And in the V-shape, why? Because it's facing the wind. So the wind will be shifted by the branch itself away from the obstacle. There will be no sand encroachment or dust in the settlements we want to save. We apply it in Ghudai, northern Kuwait Bay. This is Al Mutla area, for example. We put a preserved area around it to save it from sand encroachment. This is a proper designing for the future planning for urban cities. One of the things, cultivation is a major thing, and one of the aspects. By cultivation, we measure upwind and downwind. The dust reduced by 64.5% compared to upwind, and the sand by 95.3%. And this is a real, in fact, tell us this is a success story. When you go to the native plants, you believe in it, and you try it as adaptation method. The triangle, the angle of the road when you build it is designing of the road for aerodynamic flow of the wind. From the dominant wind direction, you should be 5% toward the wind. So there will be no shifting sand, no accumulation of sand or dust in the road. This is our general recommendation, the priority for terms of references. I think terms of references which we should establish it in the future for the urban areas in desert areas. Also the main roads in the desert, how to apply it to minimize the cost for the desert environment in Mauritania, for example, in Morocco, in Libya, and Egypt, and northern Sudan, and Saudi Arabia, and all different other countries, in China even. Sorry. Recommendation of the HIMA is one of the important recommendations. I think I summarized because I lost of the time. I think exactly in the time, by the way. Thank you very much. For the next speaker, I thank we have okay. We have Dr. Sarfaifas Bukunari from NEOM, Kingdom of Saudi Arabia. We are more than welcome. The floor is yours. Thank you.
Assalamu alaikum rahmatullah barakatuh. A very good morning to all of you. This is Srinivas, and I represent Environment Department of NEOM, and I come from one beautiful province of Saudi Arabia, which is considered to be one of the serene environments. And as a Department of Environment and as a team together with the vision of 2030, we are trying our best to keep it to the best of the, I would say, health and well-being and best of the living conditions. The advantage that you have when you get an opportunity to speak on the last day, you realize that all the topics are exhausted. Everybody have spoken extensively. That's one advantage. So I was trying to take some notes and connect the dot points. And thanks, Dr. Ali, for opening this keynotes on air quality with its relation to the health. My topic today, as you can see, is air criteria pollutants, its relation with meteorological conditions and health implications. Before I could start, I was there listening to fantastic delivery notes and speeches yesterday. Extensive elaborations of the dust, wonderful detailings on the characterizations of the dust, its categories with the infrared rays, the latest advancement technologies that was quite enlightening and learning, with the latest advancements that was shown yesterday. I'm taking it further. Probably it might be a bit of an icebreaker. Which I'm trying to do is the link between the meteorological parameters and air quality pollutants. There are a lot of air quality pollutants, but I would stick on to the criteria pollutants because that's the parameters where we are considering for something called air quality index. So if you can see, when I say the criteria pollutants, I'm quoting here the US EPA notes of the criteria pollutants or the standards. So it's very clear that we have a list of 7 or 8 criteria pollutants, typically carbon monoxide, lead, oxides of nitrogen, ozone, particulate matters, and oxides of sulfur. So when I say about these criteria pollutants, I mean typically speaking with the province of Saudi Arabia. So if we have to list out the most significant parameters out of this, would definitely be PM10 and PM2.5. Having said that, I'm not ignoring the rest because all of them are critically important to derive an air quality index. But I'm speaking of the particulate size now. We are starting with the size. That's where the whole chemistry and the dynamics lies now. So if you can see this slide, typically I'm speaking about the size of the dust ranging from 8 or maybe 5 to 10 microns, typically speaking about the size. And the question that comes is, if I'm just going back to the slide, I'm trying to connect the link. So we are highly concerned about PM10, and for all the parameters here, you can see some of them are gaseous and some of them are typically the physical particulate matters. But the question that comes is, if we are evaluating the impact of the dust or a particulate matter, you need to still have a carrier for that. And this carrier, in one way, is assessed by the windrows, or you can say the pattern where the wind blows. And when I say this, it's typically the wind direction, wind speed, humidity, precipitation, temperature, everything plays a role. So the main carrier here, I mean, if at all I have to consider the association of this particulate matter or the gaseous with that of the dust, is the dust itself, and the other carrier, because it needs to have a reaction by itself in terms of the cationic and anionic reaction. So you can see it's basically the aerosols that are coming into the picture, and you can say it's a media that ultimately helps dust reach out to different sources, especially typically affecting the health. So my focus, I mean, it will have an impact on agriculture and other aspects also, but I just want to focus on the public health and likely impact it will have on human beings if this aerosols carriage with that of the PM10 and PM2.5 increases over a period of time. Let me put you some statistics on this. Well, this is the first thing which I wanted to just put the slide in a bit of, I would say, in order. As you can see, the dust storm occasionally reaches 5 kilometers in height. I mean, typically we have to look into the, the living conditions that we are into which can be frequently thicker than 1 kilometer. And effective thickness in IR, which was found to be 40% of those values. There's a reason why I'm highlighting this is something which is very important, which is being, highlighted by Institute for Health and Metric Evaluation. This is one of the authentic institutes where most of the data is related to air quality and health is considered for certain evaluations. And you can see that there is water, there is occupational health, and there is soil and chemicals and other categories and heavy metals. But if you can see this, air pollution is one of the highest contributory factor in terms of the estimated global deaths. Now, this is probably a little bit, a different version to think about it, whether it can be really conclusive of the air pollution related to deaths, because we didn't have a significant studies done in this province yet, but this is what science speaks in terms of its affinity with human system and pulmonary system. And this is another studies which is being extracted, and this is being done for every 1 decade. You can see this is, you can also see oxides of nitrogen at the bottom, but the focus here is PM10, PM2.5, as you can see for the annual incidences of chronic bronchitis. And then you can also see prevalence of bronchitis in the children with an age group of 6 to 12, only because of this exceedance, or you can say the accumulation or exposure to PM10. There is a risk ratio which is by the end of 2015, so they do this data for every 1 decade, and there is much more data coming up to be evaluated on this. And this is also extracted from the Organization for Economic Cooperation and Development, where you can see the list of all the countries in terms of, I wouldn't say the mortality rate exactly due to this air quality or the PM10, but I would say related to almost 80% because of this exposure to the air quality or the poor air quality. And you can see Saudi Arabia also in the list, but it's well under controllable conditions, provided we come up with a sort of a strategy and connect this triangle of air quality with that of health and then the economy. I'm saying economy here because I'm just, I was also going through this data where it is being done in US. As you can see, the healthcare costs, this is also from OECD, for 2015 in US alone was 21 billion healthcare costs, and I would say 80 to 90% of them were related to a long-term exposure of, I would say, the particulate matters or poor air quality. And there is also an estimation by 2060, if the statistics have to be believed, I would say 80% of this, if considered as an accuracy, is almost 176 billion of the healthcare costs related to the air quality. This is something, a sort of, it might surprise, the numbers might surprise, but it's also real. As we were addressing yesterday, I was listening to one speech yesterday, was climate change real? And the conclusion was, at this moment, yes, it is real. So the numbers are real. So I was just referring to a case where you have 10 or 15 highly productive people, just to take an example of 10 to 15 people who are highly productive. And then you lose per day cost of those persons because of maybe the ailments related to the particulate matter or exposure, where the cost for the country or for any economy would be as much as 1.2 billion, and going forward it would be around 3.7 billion, which really attracts the case that we probably need to look into association of air quality with that of the health, and the dust or the origin of the dust cannot just be a part of an assessment of a metrology, but also should be integrated with air quality and its possible consequences. Now, I'm pretty sure all the dignitaries and the experts sitting in this hall are quite aware of this, but I just wanted to refresh. Having said that, why it's so important that particulate matter is being highlighted, because particulate matter in one way of 10, 5 to 10 or less than 10 is a representation of a dust that is also being carried because of these wind patterns. Now you can see, it's very interesting, PM10, you can see it's almost the size, I mean PM 2.5 is almost, less than that, is almost the size of a human hair. So the biochemistry or the dynamics is very interesting. If you are exposed to PM10, our system or the lungs or sensory systems are so designed that you will sense it, and you will probably have a sort of a sneeze or a cough, and you will probably let it out. But in terms of PM 2.5, you might not realize till the time when you feel that it's too excess in the lungs, because it straight away gets into the alveoli of lungs, and unfortunately over a period of time of exposure it doesn't really have a sort of a treatment, just that you need to stay away absolutely from the dust. So this is exactly which I have mentioned, the size of which is almost all the size of a fine beach sand, which is of a 90 mu microns.
3 minutes left.
So this is something which is very important to this province to be considered. And we were speaking of various sizes yesterday of the dust rising from crystals, fine dust, the silica that gets liberated in the atmosphere. You can see a electron microscope image of particulate matter. And this is being something taken in the images from the lungs
3 minutes.
of the human beings
Okunari.
upon a long-term exposure. And you can see typically that for the cement dust, for the fly ash, for the oil smoke, for the smoke, all these components can be considered under the composition or the aerosol compositions or the dust, and it's typically ranges from 10 to 100 micro. Yeah, 100, I'm almost done. I'm just highlighting the main part of it. I'm trying to imbibe the main content of it. So it's almost 100 microns. So, and this is exactly the thing. And in total, we call that as total suspended particulate matters. So what I'm trying to imply here is, we have a lot of studies done on air quality and its characteristics. We have got a lot of historical data and windrows, which we have been doing. And I'm fortunate that I was associated with NCEC as well previously, working closely for National Strategy for Health and Environment. And this was a bit of, the studies that we initiated. But I feel, given the opportunity today, I would like to really emphasize that going forward, the correlation of this air quality with that of the meteorological parameters needs to be considered, and it's an integral part, and this connection or the dots between the air quality and health for further studies needs to be explored. Got few more slides, but I think the content is conveyed, and you can see this is not just being highlighted by me. I mean, I've got this content where it started from 460 BC, from Hippocrates till John, I mean, it's up to 1673, where it was all highlighted about the requirements or the need to relate air quality and meteorological parameters on health impacts. Thank you, and I'm happy to probably give so many further clarifications of time constraints, but I think I have covered what I wanted to convey. Thank you, everyone.
Thank you, Dr. Thank you, Dr. Bokonari. Thank you. Now we have Dr. Christos Fontokis presenting the impact of ambient dust and air quality and solar energy of production in Doha, Qatar. He's from Qatar Environmental Energy Research Institute. More welcome. Please proceed.
It's coming. Okay, hello everyone. I have divided my presentation into two parts. And the first part, it's about our dust forecasting capability in Qatar, in the Qatar Environment and Energy Research Institute. I will just briefly talk about a case study, a big dust storm, one of the biggest dust storms that arrived in Qatar over the last 10-15 years, and analyze the predictions against surface observations and satellite data. And then in the next part, in the second part, I will talk about a slightly different topic, the impact of dust deposition on our solar panels, on our photovoltaics that we have in Qatar. So we use WRF-Chem for our air quality, solar radiation, and dust storm forecasting. It's really a model that is very pleasurable to work with because it never stops to keeps you busy. There are so many different combinations of aerosol schemes, gas phase chemistry schemes, boundary layer physics, surface physics parameterizations that can be combined. And it really depends, I think, on the research application, which model configuration one should use for the optimal predictions and the minimization of error. So we use two-way nesting configuration, 3 domains. We cover the whole Middle East in 50 by 50 kilometer grid resolution, then the intermediate domain 10 by 10 kilometers, and the state of Qatar that we focus all our efforts for when it comes to comparison with observations 2 by 2 kilometers. So this was a well-known event back in the beginning of April of 2015, one of the strongest dust storms. The storm was originated, as is the case mostly, from the northwest of Qatar, gained momentum over southern Iraq. And as you can see, the instrument really got crazy, measuring PM10 over 10,000 micrograms per cubic meter. These figures show AOD predictions from WRF-Chem. We simulated a few days before the event, the plume arrived in Doha, and a few days after. And the AOD difference is on the figure on the right. So basically there was an increase of more than 100% in AOD. Usually in the relatively low dust periods, AOD is around 0.4, and on average it reached 0.8 during this event. This shows day by day, 3-hour average WRF-Chem simulations of AOD. It was really an extensive event, so to be able to understand the characteristics and the movement of the plume, you need to simulate, of course, several days. And the figure panels on the top is WRF-Chem, at the bottom is MODIS. And you can see that qualitatively, the model does a good job in predicting the dispersion of the plume. When it comes to a small geographical area like Doha, it's really challenging when the event is so big and regional. It's really challenging to be able to predict the time of the arrival, the time that the plume will hit the population center, the intensity of the event, and the time that the event will die out and the city will be clean again. So these figures show shortwave radiation due to aerosols. There was a big, again, at the top panels show WRF-Chem simulations and the bottom panel satellite data. There was a decrease of about more than 300 watts per square meter due to this major dust plume. And this was, I think someone asked the other day about precipitable water. These are only satellite data. There was a sharp drop in moisture after the frontal passage that was really striking to see in the data. So basically the agreement with the observations, the ground observations and the satellite data gives us confidence for the current configuration we use for dust storm forecasting. So I'm going to move on now to the second part, which is a project that we are now reactivating. We started a few years ago, and is on the impact of dust deposition on our photovoltaics and the solar energy production in the region. Qatar has a 800 megawatts solar power plant in the middle of the desert. It's operational since more than a year ago, and there is a plan to establish 2 more power plants, solar power plants in the country, one in the north and one in the south. If we look at this map figure on the left, this shows median soiling rates on a percent per day basis for each of the countries, at least for some countries that have reported their soiling rate in the literature, soiling on photovoltaics, right? And we'll see that the state of Qatar has one of the of the highest soiling rates among these countries. Only India, if you take a look at the numbers, only India has a higher number than Qatar. Qatar has a 0.5% per day soiling rate. So why is this so high in Qatar? Is it just because it's in a dust-rich environment, or is it something more than that? And you'll see in the next slides that there is a combination of parameters that result in this situation. So we have an outdoor test facility in our research institute. You can see the photo, where we test different technologies of panels, different configurations, tilt angles, and different cleaning schedules, etc. So what we need and what we want to develop is a forecasting capability of the soiling, and to do that, we want to do that towards, optimizing the cleaning schedule that will save some money, and also finding the best locations for the solar power plants. So lately, as you know, the cost of the solar cell doesn't drop anymore as it used to be 10 or 20 years ago. So the way that the solar PV industry is looking now to reduce the cost is by optimizing the operation and maintenance of photovoltaic plants. Even in best optimized cleaning scenarios, soiling still exists and causes millions and billions of losses, of euros losses every year globally. These figures on the right show the impact of aerosols on global horizontal irradiance. Again, these are WRF-Chem predictions, with and without aerosols, averaged over a month. That is usually a very dusty month in the region, the month of May in the Arabian Peninsula. So in our outdoor test facility, we measure lots of parameters. We have a weather station, air quality station. We measure energy yield, solar irradiance, particulate matter, humidity. And this shows 1 year data. The different colors in this figure are based on different cleaning schedules, every month, every 2 months, 6 months, or never. And the y-axis shows performance ratio of photovoltaics over the course of 1 year. So we want to understand physically what are the most important parameters, atmospheric parameters, that affect this mechanism of soiling of panels and result in a degradation of PV performance. Of course, we are lucky to have many hours of sunlight in this region, but there are some parameters that are really affecting negatively the panels. It's the rich spectrum of UV radiation, the high temperatures, which are well known to reduce the lifetime of photovoltaics. So all these are contradicting parameters and deteriorating the PV performance. So basically, we started this. We simply assumed that if we measure the PM in the atmosphere, then this should give us a good correlation with the panel. So if you measure high PM values in the atmosphere, that means for these days you will have, the hypothesis is that you will have reduced performance of photovoltaics. But it turns out it's not as simple as that. There is not good correlation. PM alone is not a good proxy for PV degradation. We said, okay, maybe it's not PM10, maybe PM20, or all the particles, larger particles, or PM2.5, or whatever. PM alone was found not to be a good proxy for estimating the soiling rate. And what really plays a key role here is the humidity. So a combination of particulate matter and humidity seems to be the key factor affecting the performance of photovoltaics, because after a certain threshold, which in our case is 70% of relative humidity, the particles stick on the solar panels, they get cemented, and that's where most of the soiling happens, when it's really humid, both dusty and humid, not just dusty. So now we have more data, more than 5 years of data. We want to explore more. This was published a couple of years ago, but now we want to explore more methods, machine learning. We have more than one site, not just the outdoor test facility. Okay. We have more locations over Qatar, and we want to do this to expand this analysis. And to give you an idea why this is important to the photovoltaics industry, if we look at some dollar numbers, we'll see why this is so important. So, for example, one case is selecting the right location for your photovoltaics plant. If we, as I said earlier, the soiling rate in our outdoor test facility was measured 0.5%. The same for Al Harsa power plant in the middle of the desert in Qatar. If we selected a different location in Qatar where the soiling rate was not 0.5, but let's say 0.4% per day, for this small difference, and for the specific plant, the 800 megawatt plant, we estimate with simple back-of-the-envelope calculations that we could save $400,000 per year just by selecting a better site for photovoltaics installation. Now, if we look at the cleaning schedule, by having a tool where we can optimize the cleaning schedule, for example, let's say that for this specific power plant, we have photovoltaics cleaned every month, so 12 cleanings per year. If we use our algorithm to optimize this cleaning frequency and we save hypothetically, let's say 2 cleanings over the year, that would save us $438,000 per year. And if we consider that for the lifetime of the panels, which is usually 25 years, so you can understand that this is very important. So with that, and that's my last slide, as we all have highlighted during these days, collaboration is very important, and especially I think listening to the earlier talk, I was thinking that collaboration with the countries where most of the dust storms are being generated from, like Kuwait, Iraq, is very important to combat sand and dust storms. Thank you very much.
Thank you very much. Now Dr. Mahmoud Abu Laban from Hashemite University in Jordan about PM10 in Aqaba during regional sand and dust storms. This floor is yours. Thank you.
السلام عليكم ورحمة الله وبركاته. الحمد لله والصلاة والسلام على رسول الله وعلى آله وصحبه ومن والاه. بداية اسمحوا لي أن أشكر المركز الوطني للأرصاد الجوية والمركز الإقليمي للغبار على تنظيم هذا الملتقى العلمي الرائع وعلى دعوتنا للمشاركة فيه. Before I start my presentation, I would like to acknowledge the contribution of my co-author, Dr. Safiya Hamasha from the Hashemite University, who carried out most of the calculations, especially those related to satellite data. In my presentation, I will be talking about, I'll give a brief introduction about the area, about my study area, the need for improving air quality, then the objective of this study, how the data is acquired, and I will touch on the results, and then I will conclude by summary and conclusions. The city of Aqaba actually is located at the northeastern corner of Aqaba Gulf. It's the only seaport in Jordan. Actually, in addition, it's the only place where people actually can go and enjoy the warmth of the water and the clean sky. In addition to Jordanian residents, actually, Aqaba hosts thousands of visitors annually from all over the world. And it is kind of the main, it hosts the main port in the country. That's why actually the state of the government of Jordan have established what we call Aqaba Special Economic Authority in order to improve air quality and to ensure everything is functioning to the best in order to actually achieve the Millennium Goals of the country. Among the objectives and the goals of ACESA, the Aqaba Special Economic Zone, is to make sure that residents and visitors actually enjoy clean air quality. That's why actually they were among the first local authorities in Jordan actually to establish national, or municipal monitoring network actually to monitor criteria pollutants, to improve again, to make sure that air quality is within national standards and international guidelines to make sure actually that residents and visitors breathe clean air. The main goal of this research actually is to assess how regional dust storms affect ambient airborne PM10 concentration at Aqaba during dust storms based on historical data. There are several monitoring stations at Aqaba actually, but the one that I'm using for this presentation is located at Aqaba Downwind. Just to give you a quick review of Aqaba actually. Aqaba is kind of the city itself where people actually live and work actually is located at the north of the Gulf, while all industrial activities and anthropogenic activities, they take place at the coast itself, which means actually that if the wind is northerly, which is the case most of the year actually, no pollutants actually will be transported from anthropogenic activities, either the industrial zone or the port toward the city, because again the city is located upwind from main industrial activities and the port. In addition, actually, after actually we specify dust storms, we track them back following the backward trajectory to know and to identify the origins of the main dust storms actually that visit or invade the region, including Aqaba. Based on the monitoring actually for the whole year actually, as you can see in this chart, most wind in the city actually blow from northeast. Northeast actually again, this means that actually the wind blows from Wadi Araba toward the city and then toward the sea. Wadi Araba is kind of an empty valley. It has some agricultural activities. Otherwise, there are no anthropogenic activities, no major industries. So we can assume actually that the air which actually comes into the city from Wadi Araba is clean with respect to gaseous pollutants, but sometimes actually it may carry dust including PM10 and TSB. And you can see in the following slides that most gaseous pollutants in the city actually are well below the Jordanian standards of air quality. This is an example of sulfur dioxide. The Jordanian, we have two standards. One, our standard is 140 particles per billion, and the annual standard is 40 particles per billion. And as you can see, we have no cases where the collected SO2 would exceed any one of those standards. The highest recorded value was about 13 particles per billion, which is way below the national standards of sulfur dioxide. Same thing actually applies to hydrogen sulfide. Hydrogen sulfides, we have two standards. We have the 1 hour standard is 30 particles per billion, and the daily standard is 10 particles per billion. And as you can see, the monthly average actually hydrogen sulfide, the highest was about 7 particles per billion, which is below the hourly and the daily Jordanian standards for hydrogen sulfide. Carbon monoxide, the same story. We have the 1 hour standard is 26 particles per million, while the 8 hour standard is 9 particles per billion. And as you can see, carbon monoxide has very low concentrations at the city. Same thing applies to nitrogen dioxide. Nitrogen dioxide, the highest value was about 43 particles per billion, which is well below the Jordanian standards. NO2 actually is important for itself actually as a toxic pollutant. It's among the threshold pollutants, as my colleague has previously mentioned. It's one of the criteria pollutants because it has health impacts, but more importantly, it is actually the precursor for tropospheric ozone, the bad ozone, the ground level ozone. So we are actually keen to keep nitrogen dioxide as low as possible to make sure that there is no photosynthesis creation of local tropospheric ozone. There are some incidences where ozone could be high in the region actually because, you know, this is the nature of the Arabian area. We have too much light, which is the main actually driver for the creation of ozone. But again, because the precursor for ozone is nitrogen dioxide, if there is any ozone exceedances in the city, that would be a transboundary ozone carried into the city from remote sources. Now the story is different when it comes to dust or to PM10, which is actually the main pollutant that we are addressing in this conference. As you can see, we have the Jordanian standard for PM10. We have the daily standard is about 120 microgram per cubic meter, while the annual standard is 75 microgram per cubic meter. As you can see, we have several incidences where PM10 actually would exceed the local, the Jordanian standard for PM2.5. And this is again would be associated with regional dust storms. As you can see in this figure, actually in 2012, PM10 was high as 1,000 microgram per cubic meter, which is about 7 times or 8 times actually higher than the Jordanian PM10, the daily PM10 standard. This chart is from 2015. Again, you can see that PM10 could be as high as 1,600 microgram per cubic meter, and this is again cannot be attributed to local sources or to anthropogenic local sources. They have to be transported and brought into the city by regional dust storms. In 2020, we have actually this storm, actually the highest concentration was about 370 particle per 370 microgram per cubic meter, which is again about 3 times more actually than the local Jordanian standard for PM10.
3 minutes, Doctor.
Inshallah. We have seen actually several presentations actually trying to track dust storms in the region into their sources. And in Jordan, actually, we have kind of special location, especially for Aqaba, because actually it's located at the southeast point of Wadi Araba. Actually, it's the kind of the wind. There is like a canyon effect in the wind, how the wind actually penetrates the valley from north to south. So not all actually regional dust storms impact Aqaba. There are certain years of the year, during summer, for example. During summer, we are not impacted by regional dust storms because of, luckily, because of the wind patterns in the region. But actually, during winter, during summer, during autumn, winter, and spring, we are exposed to or susceptible to dust storms either originated at North Africa or at the Arabian Peninsula. The dust storms actually originated at North Africa from autumn all the way to spring actually are initiated because of jet streams actually try to bring cold water from the polar region toward North Africa, where actually there is a counterclockwise motion of warm air from North Africa toward Europe and toward Eastern Mediterranean, which carries actually tons of coarse and fine particles into Eastern Mediterranean, including Jordan and Aqaba in particular. a recent example actually of the Mediterranean storms actually that originated at South Europe, then actually moved to Eastern Mediterranean and North Africa was Danielle, or between 4th to 15th of September 2023 actually, where actually the dust, this storm actually has caused devastating effects actually into several parts of the world, including Greece, and the most grave incidences were in Derna, Libya, and in Jordan actually Aqaba itself was exposed to this dust storm, where actually several workers actually were hospitalized due to breathing natural dust. We have actually used the ground data to identify the main dust storms. Then, as I mentioned in my introduction, we have tracked the history of the air masses actually that initiated the dust storm, and we found actually again that we have in Aqaba and in Jordan in general, and in Aqaba in particular, we are usually exposed to more than 70% of the dust storms are originated at North Africa. Those dust storms actually tend to be stronger because of the path they travel. They travel about 5,000 kilometers until they make it to Jordan, which gives them ample time actually to pick up sand particles and bring them into Jordan. According to our findings, actually, we have, when we characterize the dust storms, we found that higher PM10 concentration could be as high as 1,600 microgram per cubic meter versus 350 microgram per cubic meter when we compare between western and eastern dust storms. We have higher aerosol optical depth, about 0.55 associated with western dust storms versus 0.35 associated with eastern dust storms. Western dust storms usually live longer, about 24 hours, while eastern dust storms actually they last for about 14 hours. Western dust storms are associated with stronger, with faster wind speed, could be as high as 7 meters per second versus 4 meters per second for the eastern dust storms. Now, when it comes to the top highs of dust storms, eastern dust storms tend to reach higher elevations, higher altitudes than the west dust storms, and this is actually justified by the fact that most eastern dust storms actually are originated because of instability in the troposphere, which actually induce strong convection that can carry dust particles vertically to high elevations. So that's it for today. Thank you again, and I wish you all the success.
Thank you.
Assalamu alaikum wa rahmatullahi wa barakatuh.
Thank you, Dr. Mahmoud. Now we have the Professor Turki Muhammad Habiballah from National Center of Meteorology, Kingdom of Saudi Arabia. Please proceed.
Assalamu alaikum wa rahmatullahi wa barakatuh. Dear CEOs, leaders, scientists, good morning. My presentation is going to be about source apportionment of atmospheric particulate in Mecca. We should start with the presentation outline, the main goals of the presentations, background, source of pollution, monitoring stations in Mecca, just describing the monitoring stations, locations, methodology, results and discussions, conclusions, recommendations, future work. Finally, going to be just show you list of publications done for particulate matters in Mecca. We start with the main core of this presentation. We carry out a source apportionment investigation for various air pollution or air pollutants The second core is identifying major emission sources that contribute significantly to air pollution in Mecca. As my colleague discussed later on this morning, I'm concentrating on PM10, and you can see a PM10 is 5 portions of a hair. Health effects, lots of epidemiological studies done in Saudi Arabia, around the world, describing the effect of pollutants, especially particulate, on health and lungs. 5 particles considered a responsibility for respiratory health effects, and you can see lots of pictures around the world. This just numbers. We can see 1930, 63 dead. 1948, lots of people, 20 dead, 7,000 hospitalized out of town. London, which is most disaster in 1952, it was between 3,500 to 4,000 deaths. I'm going to move now to what sources of particulate can affect the city, the holy city of Mecca. We have some districts and holy places. People, pilgrims, visitors come to Mecca during the holy year just to perform their rites, and especially during a month of Dhul Hijjah, pilgrims just come to Mecca and reached nearly 2 millions. This added to 1.5 millions, or another 2 millions in Mecca, and going to be 4 millions in just a few days. Source of pollutions, rock crushers. We have lots of rock crushers in the southern area of the holy city, and it's not most of them controlled, but NCFEC published lots of regulations to control all these crushers. Electricity generator in the northern area. The dominant wind, downwind, is going to be from the northern area of Mecca. We have light industry companies, vehicle repairs. We have also rock falls, crushing mountains, lots of instructions. Just come down now come up to in different places in Mecca, and we can see a lots of rock falls and just dust generated here and distributed well through the city. Of course, we have nearly 62 tunnels in Mecca. The longest one, it's about 3 kilometers. So you can imagine 63 tunnels and cars, buses, trucks, just go inside these tunnels and generate lots of pollutants, especially particulate. And you can see in the right picture, people gathering with vehicles and buses. We have light duty vehicles, we have heavy duty vehicles, all these during a Hajj, just gathering together and just exhaust lots of pollutions, can affect people. Monitoring stations, we have chosen 5 sites. One of them is just near to the holy mosque called Misfala, the other one near to holy places called Azziya. And we have just, let's say, nearly district people or live in Iskan, called Iskan. And we have the northern area, which is Sanaiya, which is near to electricity generator, and we have in the northern, in the southern area near Arafat, called background. Sometimes we call it background Abdiya. These stations have been taken, so Azziya we have collected in different environmental types. Azia is traffic sites, Sanaiya is industrial site, Abdiya is background site, let's say nearly background sites, Misfala urban sites, Eskan is residential site. I would like to show you just something. We have using a high volume sampler, and you can see this filters of two areas. One of them is Abdiya, the other one is Azia. You can see Azia is nearly to black. This is just 24 hours captured. So I think sometimes it's going to be the loss of pollutions, yeah, especially particulates. The methodology, we have used a high volume sampler, collected, considered one of the most widely used devices worldwide due to their simplicity. Sample calendars, we have divided our sampling into a week during the year of between 2019 to 2020. PM10 analyzed and got 10 ions, cations and anions, which is fluoride, chloride, nitrate, chromate, and etc. by using ion chromatography. Also, we have used atomic absorption to get the heavy metals, lead, cadmium, chrome, arsenic, selenium, aluminum, by using atomic absorption. The first results going to just describe the area, the mean and minimum, maximum. You can see the maximum for all of these sites exceeded the 24 hours standard limits of Saudi Arabia. Standard limits is 150 microgram per cubic meter for 24 hours, not exceeded more than one time a year. But here, I think mostly exceeded all samples we have taken from these stations. And you can see in Azia, which same filters I have presented to you, it's now here, the maximum one is 739. It's about 5 times double, or 5 times double the standard, or 3 times double standard. These are concentrations in the right, the concentration of PM10, and you can see this chart actually describe Abdiya, Azia, Eskan, Misfala, Sanaiya, and Azia is most increasing of particulate PM10 compared with the other sites. In the middle one, major contributions, you can see aluminum, cadmium, calcium, chlors, sodium, sulfate. The sulfate is it's highest the standard. We have Saudi standard of sulfate it's about 25 microgram per cubic meter. Here it's exceeded the 25 microns, and the minor pollutants, you can see it here, differences between Abdiya, Eskan, Azia, the Azia. One thing we can conclude it from these three graphs, Azia is most pollutant area because it's a congested area. Lots of people just live there because of near to the holy places. One of the holy places is Mina. The other one is Azia. It's well structured, so people use Azia just to stay there during doing their Umrah all the year. So people just like to stay in Azia because of lots of marketing, lots of facilities. So this reason, we can see a increasing of pollutants.
2 minutes.
Yeah. This time variation, this is a monthly variation, and we can see August, September, it's the highest concentrations of PM10 in Mecca. also June. And the left one and the middle, it's concentrations of all pollutants, anions, cations, heavy metals. And we can see also the sulfate, get the highest concentrations here during a year. This correlation plots, we can see here, there is a correlation between PM10 and magnesium fluoride. So magnesium has come to 83, fluoride 75. The weakest correlations with the PM10 was aluminum and arsenic. We done positive matrix association. 4 factors. Factor number 1 related to industrial emissions. Factor number 2, fossil fuel consumption. And road traffic factor 3. And factor 4 is restaurant. And we can see factor 2, it's about 7. It's about 7. And factor 3 is the highest one, 51, related to traffic. We conclude with this discussions. Emissions from traffic includes exhaust and can generate fluoride, sulfide, nitrite, etc. Mineral dust can generate this one. Industrial concentrations can generate other marine aerosols, chlor, chromium, and magnesium, sodium. Conclusion, road traffic includes exhaust and non-exhaust emissions, industrial emissions, and mineral dust. In 27, the most important one, so road traffic's got 51%. Conclusion, we know that Mecca is the most populated city in this region during a month of Ramadan, Hajj, and a lot of people just come to Mecca, and the pollution can double the other months during a year. PM10 in Mecca generated natural sources, dust source, as well anthropogenic sources due to road traffic. We send a lot of recommendations to stakeholders designing specific alarm systems just to decrease the particulate. We required a lot of studies regarding source of pollution. Also, this study showed the measure of pollution in Mecca for human activities, create realistic emissions standards. We need to create realistic emission standards for air quality environment, and this is what we got lots of meetings here just to increase the awareness of that one, investigating the health impacts of PM in Mecca. This also recommendations, further recommendation of public transport, tackling actions of encourage activities. Future work, establishing, this is the most important one, establishing a new air quality index in Mecca, create realistic emissions standards. These publications done in Mecca between 2005 and 2024, and I can share all these publications with as interest with other researchers. 2014, 15, 15, 17, 17, 22, 22, 23, and we have now new publication 24. Thank you.
Now to the last presenter from the Egyptian Meteorological Authority, Dr. Zainab Abdullah, about the assessment of the intensity of dust events over Egypt with climate change scenarios. Please, the floor is yours.
Assalamu alaikum. Good morning, everyone. Today I will talk about the dust event over Egypt with climate change. So, dust storms as everywhere in our region, are common phenomena in Egypt also, which extend to hundreds of kilometers, especially during the spring and winter. This is the main season for dust storm. Sand and dust storm have direct impacts on the health, crop productivity, land, sea, and air transport, and infrastructure, and sometimes lead to death and destruction of property as a result of the associated strong wind and deteriorated visibility, as what happened in the very heavy dust storm that struck Egypt on 1st June of the last years. As you see in the picture, there is a wall of dust. This started as the normal dust storm because of the Saharan cyclone, and after that extended to the east of Egypt, and because of the strong downdraft from the cloud, this is what happened, the wall of dust storm. The wall of dust cover all the area. This is unusual for us. This, the normal dust storm come from the west and pass to Egypt without make this wall of the dust. So after recent changes in our extreme event we experienced in Egypt during the last few years, some extreme event as heavy precipitation, elongated long heat waves, and strange dust storm. So before that, we thought about how to the dust storm will affected by the climate change. So we used the ICTP regional climate model, version 4.7, to study this, the effect of climate change on the dust storms with two scenarios, RCB 4.5 and 8.5. Okay. This is the methodology and the model configuration. In the beginning, we ran the model using the Max Planck Institute data with a resolution 1.8 degree with two scenarios over all the MENA region, starting from 1978 to 2100, and then make downscaling over Egypt and surrounding area. So part from Libya, part from Sudan, and Saudi Arabia. And this is the dynamical core, MM5 hydrostatic, and these the schemes we used. Okay. And here, it's normal to run the model, the original climate model, for atmospheric parameters as temperature and precipitation and radiation, but now we run it with the dust module to see what will happen in the future projection. Okay. As the projected monthly mean climate extremes indices were calculated from the output directly, we calculated the climate extreme as the number of heat waves, the number of cold spells, the percentage of extreme rainfall or moderate rainfall days. We thought that why we don't apply the same idea on the dust. Also, we use the same idea of sand and dust storm center in Barcelona when they make an early warning system over Burkina Faso. They make the same idea. So we apply the same idea in the projection and then use the output of the model, the dust concentration, resulted from the run of the model, and then calculated the maximum daily dust concentration over every grid point in the area, in this area. Okay. 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 No. Is it? Okay. Sorry. I want to return again. Okay. Okay. How to return again? Okay. It's, okay. 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 Yes. Yes. See. We calculated the maximum concentration over this area at every grid point. And then started to calculate the time series of the maximum concentration during the reference period from 1980 to 2005. This is our reference, and then use this reference to calculate the thresholds. Make categories for dust storms. Moderate dusty days is at 75 percentile, high dusty days for 90 percentile, and very high dusty days 95 percentile, and extremely one is 99 percentile. Then use this percentage of occurrence of these different categories to study the, what will happen in the future with the different scenarios. Okay. Firstly, we studied the air temperature, what will happen in the temperature with the two scenarios. On the left, you will find the trend in the mean temperature with scenarios RCB 4.5, started from 2021 to 2100. Approximately all Egypt has positive trend, approximately 0.2 degree per decade. And on the right, the trend increased with RCB 8.5 to be more than 0.4 degree per decade. Okay. Also with precipitation, all Egypt, all the eastern part of Egypt, there is a negative trend of precipitation, and just the small part in the west have a positive trend, but with scenarios 8.5, approximately all Egypt has negative trend in total precipitation. So with high temperature and low precipitation, it's normal to expect that we have increase in the dusty days. So we calculate the moderate dusty days, any values more than 75 percentile. In the higher figure, this is the reference. We calculate the percentage of the dusty days or moderate dusty days from the period of 1986 to 2005. This is the percentage of the moderate dusty days over this year. And then after that, we calculate the rate of a change with every scenario. As you see that approximately we have no change in Egypt, but except in some places in the middle of Egypt. Okay. This increase in the percentage of dusty days. Okay. Okay. And this is the same thing we do for high dusty days, more than 90 percentile. This is the reference, it's a percentage of high dusty days, and then the rate of a change of them. The number of, or the percentage of high dusty days increased with every scenarios, as you see. And this sample, all this sample from the result, we plot the time series of high dusty days over some cities, over Cairo, over Aswan, over Al Arish, and Hurghada. From the scale on the left, you can see that the highest value in Cairo, but in Aswan it's lower than Cairo, maybe because it's in the south, so it doesn't affected by the dust directly. Al Arish, also in the eastern of Egypt, the numbers is more or less than Cairo, and also Hurghada. It's all of them less than Cairo. The red line is RCB 8.5, and the blue line is with the scenario RCB 4.5. And this is the same for very high dusty days. The values more than 95 percentile, and extremely dusty days, the values more than 99 percentile. You can see that the number there is a increased in the number or increased in the percentage of the dusty days, the very high dust days and extremely one, with two scenarios. Okay, this is the summary and conclusion. It's a very short summary. An indicator for the dust event can be calculated directly using the dust storm, using the dust concentration from the original climate model, coupled with dust, of course. And the result of this study shows that there is a positive trend in air temperature over Egypt, accompanied by a negative trend in precipitation with RCB 4.5, and this negative trend increased with RCB 8.5. So this will lead to increased dust emissions. Our future work, inshallah, to study the impact of land use change of some regions in the western Egypt near to some dust sources. After new agriculture projects there, what will happen when we make agriculture community in these places on the dust storms, frequency and intensity of the dust storm, and of course to publish or to complete the paper of this work. Okay, last thing, this work was carried out within the project of interactive map of climate change scenarios and its application for the Arab Republic of Egypt, which was implemented by the Military Survey Department, Egyptian Meteorological Authority, and the Water Research Center at the Ministry of Irrigation, and funded by the Ministry of Environment. And the duration of this project starts from 2017 to 2023. And this is the reference of all scheme we used in this to run the model. And thank you.
Thank you very much. Thank you, Dr. Zainab, for the nice presentation. Now we have 15 minutes for any question for the audience. Anyone can raise his hand? Yes, Dr. Majdi, please.
Assalamu alaikum. Thank you, Prof. Turki, for your presentation. I'm really impressed. One of your recommendations at the end is to investigate the impact of PM10 on public health. Did you see or did you apply any link correlation between the highest value of PM10 in Azizia or Sanaiya and the hospital admission through the area during that time, to link and investigate actually how the PM10 affecting the upper respiratory disease or any public health risk value during that time?
For your question, Victor.
For me.
Okay, please.
Thank you, Prof. Majdi. It's a good question. We had a lot of projects with the Ministry of Health. We done lots of analysis with some pollutants like particulate, and we run a model called the RQ model, which is well known just to calculate the health effects. Yeah, when a human can breathe some doses here from particulate. Yes, we done a lot of studies, but what I mean for that one, it must be a continuous programming because concentrations can vary between year to year to another year, can vary between season to another season. You know that, and most of us know that we have a lot of seasons here in Mecca, especially during the Hajj and Umrah. And next week, inshallah, b'idhnillah, it's going to be Ramadan. Everybody, inshallah, b'idhnillah, have life to get fasting during Ramadan. And we can see how a huge amount of people just come along to Mecca and perform. Yes, we done a lot of studies, and we done a study regarding to health, and we have different doses between elderly people and youngest people, and we published that study. But what I mean, we need a continuous, we need a projects, continuous studies just to highlight the health effects of all pollutants, not just particulate. Particulate is the most important one in parallel with the CO, but we need a continuous projects funded by government. Thank you.
Assalamu alaikum, good morning. My question is to you, Dr. Ali Dosri. On the project of Iraq, did you have in place a system of measuring the effectiveness of the interventions in reducing the sand and dust storm episodes on Kuwait? So do you have that sort of scheme or framework to measure the effectiveness of your intervention in Iraq on Kuwait? The second question is about, do you have a plan to scale up your interventions within Iraq and within neighboring countries within the project that you have? Thank you.
Thank you, Dr. Abdul Majid. In fact, the project began 2 years ago, and fortunately, in fact, we are proceeding. One of the major two areas is being stabilized naturally. The reduction of the two areas reached up, one of the areas reached up to 84% compared to 1968. We compared the area, it was more than, mostly bare land, no vegetation at all. Now it's being by native plants. There is a growth of native plants in the borders, and reduced up to 84% now in 2023. We expect that naturally it will be covered by native plant naturally in 2035 to 2040 between these two areas. So there is, sorry. There is no dust storms will be initiated from the two source areas in future. After measuring the dust storms which affect the aviation and affecting the health aspects, whatever, 40% of the dust storms comes to the Gulf region are coming from the two areas. So stabilizing these two areas will make a huge difference for the community. For future planning, we are planning for other hotspots. So this is the target. In fact, one of the major aspects during this conference, Marvelous Conference, is regarding what's the next step as a solution for adaptation method with the dust. The dust is a part of the ecological system. We don't want to look at it as a threat, but as part of the ecological system, it has benefits out. But go to the anthropogenic sources or affecting the economy or health, we try to stabilize it in future. So our next step is the other hotspots in future in order to reduce the amount of dust storms and the haze or dust phenomena. At the front here.
Assalamu alaikum. Good morning, everyone. This is Dr. Abdulaziz Al Ghamdi, Chairman of Soil Science Department at King Saud University. I have one question for you, Dr. Ali. If anyone go to this Google Scholar, we have a lot of papers related to dust and PM10 and PM2.5 and etc. But we have a limited research or publications related to the wind erosion. And if you know that wind dust and PM10 and etc. caused by wind erosion, could you please tell me, Dr. Ali, about how important to do some research in our region by wind erosion?
Understand that your question is regarding if there is a future planning regarding research within the dust in the regional scope. Is that what your question about?
My question is, how important of study the wind erosion in our region?
Of course. By the way,
because we have a limited research on wind erosion.
Wind erosion is related to the, in fact, from the source area of the dust hotspots. We call it, by the way, hotspots is the terminology used by 3 agreements of United Nations. So it's a source area and go to the positional area. So whenever the wind passes, it's you can identify the paths of the dust storm or trajectory, we call it, dust trajectories. These are these can identify even though we can take a benefits from it. For example, we can use the paths for the wind energy. And we find in Kuwait some paths comes to Kuwait, the best paths for initiating or installing a station for wind energy production. Other things, the wind, we calculate samples from the source area in Iraq, and we collect samples of dust in Kuwait. And we study it from a logical point of view, and saw huge similarity between them. Radionuclides also, and pollen analysis, many other aspects, grain size, and I think in future planning, in fact, control it by native plants, the original areas. Anyone? Okay. I have a question for Craig, if there is no question from audience, is regarding, we have in Kuwait, we find that the wind energy produces 10 megawatts station produces more by 2.4 than solar energy, the same 10 megawatts. So wind energy is more prevalent within the region, especially in Qatar and Kuwait and other. Other thing is the cracking and problem and the temperature durability of the solar panels. We find it in fact huge, in fact, within our region. I make a book inside, if you can pass to it, regarding the solar energy difficulties in the desert regions. It's not like the durability in the Europe or America. Durability is very low, unfortunately. The cracking, many other aspects, the aerosols, dust, and many other. I have your opinion. Thank you.
Yes, I totally agree. It's a very challenging area for photovoltaics. I'm not an expert on this, so I'm looking at this from the ambient PM and humidity, atmospheric parameters. But I totally agree that, yes, the high temperatures are challenging. For the wind energy, I don't know. We haven't done any studies on wind energy in Qatar. But yeah, there are many challenges in this harsh environment for photovoltaics.
Thanks, Dr. Ali. I have one question to Dr. Mahmood. Thanks, Doctor, for sharing that extensive studies done on PM10, especially. Well, I have in one of the slides where you have demonstrated the PM10 hitting around, say, the peak of 1600 micrograms or the max, where you have concluded that this could be attributed to some of the natural sources rather than just the anthropogenic sources. But I was just trying to understand that while evaluating or considering the values of the peak for PM10 as per the standard processes by US EPA, there is also a clause stating if anything that is being contributed by natural sources, or could be some sand or dust storm, can probably be eliminated from the result. Otherwise, that would probably impact the air quality index as well. So you have taken that as a point of consideration, or it's being outlayered in your calculation?
Actually, the data actually is PM10 is monitored continuously at Al-Aqaba. There is no effort actually to do kind of segregation to relate exactly the PM10 or PM2.5 to their sources in a study like what Professor Turki has done in Saudi, in Mecca al-Mukarramah. So the data actually presented in this presentation is what's actually what we got from the analyzers. We use the beta gauge analyzers, actually beta gauge to collect the PM10. So I agree with you, with my colleague, actually, that this number is 1600 actually could be attributed to anthropogenic sources or to, in addition to natural sources. But as I mentioned in my brief description of the monitoring site, actually Al-Aqaba, the city itself, the population of Al-Aqaba is less than 200,000 inhabitants. They live at the northern part of the area. The industrial zone actually is located at the southern part of the area. The monitoring station is at the middle. And because of the nature of the city, actually, it's at the southeast end of Wadi Araba. The wind actually is northerly or northeasterly from most of the year around. So this means actually that the monitoring station is upwind from the main industries and the main anthropogenic activities. In addition, actually, this number, the 1600, actually is not only recorded in Jordan. Actually, there are other studies in the region, like Greece, Turkey, North Africa. They are actually they're seeing similar numbers, especially when we experience dust storms originated at North Africa, because, as I mentioned, the cyclones that develop at North Africa usually at the Atlas Mountains, they travel about 5,000 to 6,000 kilometers until they make it to Jordan, which enable them, actually, the cyclone, I mean, to pick up lots of dust particles and transport them through, including into Jordan. So we have, so the number, the 1600, this is actually high, but if we remember what happened actually in Derna last September, actually, we could actually realize and figure out that this is not unusual. Actually, this is common, and as Dr. Zainab has mentioned, global warming and climate change may bring up more storms like the Daniel storm, especially when we know that actually the direct cause for Daniel was actually the high temperature of the water in the Mediterranean. The water temperature in the Mediterranean has reached unprecedented values of 26 degrees. And you know, tropical cyclones usually develop when water temperature increases or rises above 26 degrees. So this symbolizes what happened in the Mediterranean symbolize what happens in the tropical storms. That's why some authors actually they like to call the Danielle storm as a Medicane. Medicane is a storm that formed in the Mediterranean but has the characters of tropical cyclones, which are usually associated with very fast wind that can carry tons and thousands of tons of sand particles and carry them, distribute them regionally and globally.
Thank you, Dr. Mahmoud. Thank you. At the end of this session, I would like to thank the organizers, all the presenters, Bukunari and Dr. Chris, Dr. Mahmoud and Professor Turki and Dr. Zainab, and the audience for listening, and I leave the floor for the organizers here to the next step.
Thank you, Dr. Ali Dosri, for chairing this session. Now it gives me great pleasure to invite His Excellency Dr. Jam'an Al-Qahtani, the Executive Director of WMO, to honor the speakers, starting with Dr. Ali Dosri. Dr. Srinivas Pukonari. Dr. Christos Fontokis. Dr. Muhammad Abul Alban. Professor Turki Habiballah. And last but not least, Dr. Zainab Abdullah. Just to remind you, we'll have a break now until 11:15. Now we'll have a photo group. During this break, you are welcome to have the refreshments, snacks, coffee, outside the main auditorium. Also, we have a scientific exhibition or pavilion. It's outside to my right and your left. If you, we would like to encourage you to visit. We have also a Bedouin tent, in addition to a falcon. If you want to take a photo with the falcon, you are also more than welcome. Enjoy your break. We shall be back at 11:15 for the second session of the last day of this conference. See you soon.
Is it working? Yeah.
Assalamu alaikum wa rahmatullahi wa barakatuh. We will start in 5 minutes, so please proceed to the main auditorium so we can start the second session of the last day. Thank you very much. سنبدأ بعد دقائق. الرجاء التوجه إلى القاعة الرئيسة لبدء الجلسة الثانية من اليوم الأخير. Thank you. شكرا. Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to the second session of the day titled Impact on Solar Energy, Weather and Climate. It will be chaired by Professor Georgi Stanochovic. And before Dr. Professor Georgi starts, let me give you a brief about him. He graduated with a distinction from Moscow Physical Technical Institute in 1973. He completed his PhD in the numerical and analytical study of the weak plasma turbulence at the Moscow Physical Technical Institute in 1977. Afterward, he headed a department at the USSR Academy of Science, which used the computational analysis to carry out the crucial early research into the impact of a human on Earth's climate and the climate consequences of nuclear war. He also contributed to the Nobel Prize-winning report from the Intergovernmental Panel on Climate Change. In addition to this, he received the Future of Life Institute Award for developing and popularizing the science of nuclear winter. The floor is yours, Professor.
Thank you. So our session is about dust and climate, so we will continue the topics what were discussed in the previous sessions. And we have 6 presentations, and I will ask the presenters to take their place at the table. Please come here. Okay, so I will have keynote lecture at the beginning, and after them we will continue according to the program. And I will introduce the speakers on the way. It is too much. Thank you for coming, and thanks NCM and the center, as the center for organizing this very important meeting. So I'm Georgi Stenchikov. So my expertise is in impact of aerosols on climate and different aspects of life. So I worked with aerosol effect, with the radiative effect and climate effect. Looking at different type of aerosols that was soot from the fires and that were volcanic aerosols in the stratosphere after volcanic eruptions. And since 2009, I'm a founding professor at the King Abdullah University of Science and Technology. And since then, I focus on the effect of dust in this region, because this effect is extremely important for this area. My group was involved in studying future climate projections in over Arabian Peninsula, dust cooling effect on the regional seas. We quantified the effect of dust on the Red Sea because it has the largest in the world radiative forcing that reaches 60 watt per meter squared. We looked at dust effect of circulation, and we found, for example, that Saharan dust shifts the rain belt in Africa to the north in summer and increases precipitation in Sahel. We look specifically at dust precipitation, interaction between dust and precipitation over Arabian Peninsula. I have to say that the up-to-date natural clouds are already pretty heavily seeded by dust particles, and this has to be accounted for in seeding experiments. And we looked at the dust effect on air quality, so my approach is mostly modeling. So we use model to integrate all available information and to do process analysis. But as we know, so all models are wrong, but some of them are useful. This is actually was said first about statistical models, but it, to some extent related to physical models as well. To make model more useful and relevant, so we have to use observations. That's why, so together with modeling studies, we developed some observation campaign, routine monitoring of aerosols at coast, and I will talk about this. And the most important part of this monitoring was measuring of size aerosol deposition and size distribution of aerosol particles. And on the right, you see, so usually dust models are tuned. Dust generation is a very complex process. And none of the models describe this dust generation in first principles. I don't go into the details why this is not possible, so models have to be tuned to produce reasonable dust concentration and radiative effect. And first tuning parameter is optical depth, and you see on the right comparison with IRANET. And usually we can reach this agreement, but this shows us the amount of dust in the atmosphere. We also tuned the model looking at size distribution obtained from IRANET. This is very useful comparison, but it is losing the effect of large particles, as Oleg Dubovik talked yesterday. When we compared our deposition measurements with model predictions and with the results from the best reanalysis products like MERA2 and CAMS, we found that all products underestimate the total deposition of dust about 3 times. And this will be one of the topics what I will try to discuss today. Could you move it forward? Yep. So dust is a variable. This is results from our paper, I don't know, 6 years ago. And that time, so we detected positive trend of dust optical depth over Arabian Peninsula. After then, in 2015, that changed. And the reason for this are multiple, including natural and anthropogenic ideas and forestation, artificial forestation that is going on. But natural component is very important, and we have to better understand it. This is just curious effect of dust optical depths in summer obtained from observations. This is climatology from MODIS. And you see a big block of very high optical depths of the order of 1 over the southern Red Sea. And this, so physically it is absolutely understandable. In summer, the winds are going from north to south and put the dust that shifted to the Red Sea Canyon to south, and height of the mountains along the coast in the south is from 2 to 2.5 kilometer, and this 2.5 kilometer layer of dust produces optical depth of 1. And this produces very strong effect on Red Sea, and we studied this effect specifically, and so Osipov and Stenchikov was published in Journal of Geophysical Research. For this, we developed a unique model. It is coupled regional ocean atmosphere model. We coupled WRF with ROMS, regional ocean modeling system, and we simulated this impact of this very high dust optical depths on the circulation and temperature of the Red Sea. As I said, so to make our models more relevant, we developed the set of the observation of monitoring at KAUST. And we started actually from analysis of soil samples over Red Sea coast. And routinely, we established in 2012, we established IRANET site at KAUST. From that time, from 2012, we do routine measurements of optical depths over Red Sea using handheld sun photometer microtops. We established LiDAR site at KAUST to measure vertical profile of aerosols. And we also do routine measurements of dust deposition and mineralogy of deposited samples. All IRANET and sun photometer measurements and LiDAR are done in cooperation with NASA Goddard Space Flight Center, and all data are available at the NASA Goddard website. You can access it and use for your research. So to make sense from, for example, LiDAR observations, we cooperate with a group of Oleg Dubovik, and we developed the specific algorithm to retrieve extinctions and aerosol loadings from LiDAR backscattering. You see this on the left. And in this sense, it is very important to have collocated IRANET and LiDAR in the same place, that this increase the accuracy of retrieval algorithm. On the right, you see the observations, our first observations of dust storm using our IRANET station. So it shows optical depths up to 4 detected at KAUST site. It was a very big storm in 2012. They started somewhere in Kuwait and moved through entire peninsula and ended up in 5 days in Pakistan. So this storm lifted up about 100 million tons of dust, and everything what was lifted was deposited in different places in the regional seas and on solar panels in other places. Here are results of our soil samples analysis that shows electron microscope images and X-ray diffractometry and size distribution of the samples, as well as mineralogy of these samples. The deposition program we started 7 years ago. We use very simple device as shown on the left. We collect dust in this frisbee shape plate in sponge, and after then wash it out with distilled water and process the samples. We have sites also on the island in the Red Sea to see the difference between coastal and nearby sea locations. And there we have to struggle with birds that destroy our instruments. So it appears that analysis of dust deposition samples is pretty, hard-working process. So we do mineralogy, particle size distribution, chemical composition. We have to freeze, dry freeze the samples. The analysis of one sample takes more than 1 week. And after then we have the samples and do further analysis, and the latest results are published in the paper by Shevchenko et al. You see the reference here. And here are the instruments what we use for this analysis at X-ray diffractometry and Malvern master sizer to measure size distribution. And on the right, you see mineralogy of dust samples, and you see deposition as a function of time, at coast sites. It varies from 10 to 20 gram per meter squared per month. For modeling studies, we use WRF-Chem. In nested domain, we run WRF-Chem with 10 kilometer resolution and better until 1.5 kilometer, and now we run even with half kilometer resolution. Here, what we found on the right-hand side, you see the formula what we use for generating dust. As I said, so this parameterization are relatively simple and have to be tuned to give reasonable results. The table shows the size bins that we use in our studies. And the largest particles what we have in these sizes is 10 micron in radius. And if we look on the left bottom, size distribution, what we got from deposited samples, you see that we have sample particles up to 100 micron. So the models do not consider large particles, and that's why we see that big difference in deposition and simulated and observed deposition. So if we talk to compensate for this, we increased deposition of large particles and tuned our emission parameterization to produce, to emit more dust particles. It happens that we have to put about 70% of mass in the emission of large particles. Our publication in Journal of Geophysical Research came this year, earlier this year. Returning back to the question with large particles, they are not very well detected by IRANET, for example, because IRANET has longest wavelengths is in near infrared, and it is not very sensitive to large particles. They are seen better in infrared, but most importantly, they are very well seen in deposited samples. So our idea was to use our observations for dust deposition to tune the model to produce right deposition rates. So we tune model from both sides. We tune model for optical depths, and in this sense, we reproduce small particles. And we tune model for dust deposition, and this allows us to reproduce large particles. And as you see, the red line, so we can reproduce deposition pretty well now, and the bias disappeared. We can so continue to will reproduce the optical depths, the amount of dust in atmosphere. And on the left bottom, so you see our simulated size distribution in simulated deposits and in measured deposits. And you see we can reproduce size distribution in measured deposits very well now. And we also reproduce size distribution, but now we have the blob of large particles on the top of the observed IRONET distribution that IRONET does not discover. If you look at the results, I present these results discriminating to the size of the particles. So starting from fine to giant particles. And we see that optical depths, visible optical depths, is produced by particles, by small particles less than 3 micron. And giant particles produce very little of this optical depths, as well as radiative forcing. So they, large particles produce less than 10% of shortwave radiating forcing. But they are more important in long wave, but long wave itself, so much smaller than short wave. And in this sense, so it is very important to have large particles to produce right deposition rates. And their contribution into the radiative properties is more significant in long wave than in short wave. We also calculated deposition over Arabian Peninsula and in the regional seas. So over Arabian Peninsula, accounting for large particles increased deposition about 3 times. And in regional seas, about 2 times. And we see the gradient of deposition in the seas. Large particles cannot go to the center of the sea. They deposit near the boundaries, but so still it is very significant contribution in deposition, what we underestimated in the past. So this, you see seasonal deposition rates, and on the right-hand side, you see decrease of the downward solar radiation that suspended dust produces at the surface. So I jump in this moment to the impact of dust to solar panels. And this impact is twofold. The first, suspended dust decreases incoming solar radiation. And the second, deposited dust produces soiling of soiling losses. And we can represent soiling losses and attenuation losses in the form I showed here. So decrease in incoming radiation weighted to total radiation coming to the clean panel. And total losses will be sum of soiling losses and attenuation losses. So soiling losses we can calculate, and they reach about 10%. If you go to attenuation, to soiling losses, we proposed so the analytical relation that is different from so I saw in the literature. In the literature, it is considered using Mie theory. So roughly, the attenuation is calculated by assuming that individual particles reflect and scatter solar radiation. And this came to the conclusion that smaller particles are more important than large particles. We considered the process slightly differently. We assumed that dust produces uniform layer on the surface of the panel and calculated transparency of such a layer. And here you see SL equals something, and you see H here. H, it is the depth of this dust layer on the surface that is proportional to deposition rate. But in this conclusion, we see the results numerically similar to what was obtained previously. But conclusion is different because the major contributor to deposition are large particles. So we have to account for large particles to calculate soiling rates. Of course, it is a simplified result, and we have to account for sticking and dependence on humidity, but this is very encouraging results that we use for analysis of observations and calibrating the soiling losses. And finally, WRF-Chem model constrained both by optical depths, aerosol optical depths, and dust deposition observations reproduces the observed deposition rates and optical depths very well. Enhancing the emission of giant dust caused a tripling of dust emission and dust deposition over land. Over regional seas, dust deposition increased 2 by 2.5 times. Giant dust comprises only 26% of loading, so it doesn't stay in atmosphere too long. It is short-lived particles that are emitted and fall down. So the amount of dust in atmosphere increased only 25%, and impact on shortwave radiation is not very large. Giant dust contribution in shortwave forcing is less than 10%, and in long wave it is less than 30%, but long wave is relatively small. PV panel efficacy loss for attenuation is about 3.5%, and PV, so it is uniform. And for soiling losses accumulated per week will be about 12%. So it is about 2% per day. Thanks very much. So we will continue. Let me introduce the next speaker. The next speaker is Mr. Ayman Albar. Mr. Ayman is the Executive Director of the Regional Cloud Seeding Program in the National Center of Meteorology in Saudi Arabia. He also is Director of Weather Modification Department at the NCM.
السلام عليكم بسم الله الرحمن الرحيم Okay, good morning. I think this is not the right presentation. Could we have the next presentation? I think this is the old one and I need to replace it. So if we could shift the presentation to the one who's after me. I think by mistake they have an old presentation.
So, is it yours?
No, it's an old one for another. So if you could present another, if you could give the chance for another presenter to, or another speaker, so I will replace this presentation with another one. Sorry.
Whose presentation? It is yours?
Presentation, I would need to replace it.
Okay.
So just give me 5 minutes.
Professor, can we proceed to the next speaker, please?
So we want to have the next presentation by Asma Saroji. Asma, please. So Asma is electrical engineer working in cloud seeding system and NCM. He has multiple talents and expertise in robotics, Internet of Things, machine learning, and she will talk about cloud seeding.
Thank you so much. Assalamu alaikum wa rahmatullahi wa barakatuh. It's Engineer Asma speaking from the Regional Cloud Seeding Program within the National Center for Meteorology. So today I'm going to present Advancing Atmospheric Insights, Studies and Operations of KSA's Cloud Seeding Research Craft with the latest technologies we have in the regional cloud seeding, as well as some findings. Next. Okay. So the Regional Cloud Seeding Program was established by His Royal Highness Crown Prince and Prime Minister Mohammed bin Salman Al Saud, may Allah protect him, in the 2021, in accordance with the Kingdom's Vision 2030. So the Regional Cloud Seeding Program is one of the main key elements of the Saudi Green Initiative, Middle East Green Initiative, as well as the Vision of the Kingdom 2023. Okay. In 2023, the Minister of Environment, Water, thank you, which? To move it forward. Okay, thank you so much. So in 2023, the Minister of Environment, Water and Agriculture, His Excellency Engineer Abdurrahman Al-Fadli, signing a deal for 5 state-of-art aircraft in cloud seeding operation and also one research aircraft to study the cloud microphysics. So the project aims to build internal capabilities, transfer and localize knowledge, as well as improve the efficiency and the coverage of cloud seeding operations. So, as I said, 4 cloud seeding aircraft and 1 research King Air Model 360C for researcher and climate studies. I'm going to talk about the King Air 360C aircraft. So the equipment of this aircraft is geared toward comprehensive atmospheric sampling and measurement, providing a range of data crucial for understanding the microphysics of cloud, aerosols, and precipitation. This research aircraft contains of more than 16 advanced instruments in order to understand or gain more understanding of cloud, aerosols, particles, and cloud microphysics. I'm going to talk about the research equipment in the research aircraft in the right wing. So we have almost 5 research equipments. The first one is precipitation imaging probe. So this is an imaging probe and incorporating a laser and optical diode in order to measure or study the cloud size and shape, as well as the orientation of particle. The other one we have cloud droplet probe. Basically, this one is used to measure the cloud droplet size distribution, almost from 2 micron up to 50 micron, and it could be used with an appropriate data system to calculate other various parameters, such as particle concentration, effective diameter, as well as the medium volume diameter and liquid water content. We have another one, which is King probe. This King probe, it's mainly used to measure the liquid water content within the cloud. We have the 4th one, which is aircraft integrated meteorological measurement systems. It consists of 3 modules. The first one is air data probe. We have also the initial measurement unit and as well as the central module. We have also the cloud image probe, which is basically a single optical spectrometer, which is used to study or measure different parameters such as the humidity, air speed, and air velocity. In the left wing basically consists different instruments which could be used in measure aerosol particles. We have the first one, which is cloud aerosol and precipitation spectrometer, CAPS. So basically CAPS is an advanced spectrometers consist multiple sensors to measure the size of aerosols from almost 0.5 micron up to 50 micron. This is an advanced instrument. We have also another one, which is passive cavity aerosol spectroprobe. This is basically because also specialized in measuring aerosol size distribution from 1 micro up to 3 micro. So it's important to have multiple instruments or group of instruments to measure different range of size, particularly to improve the accuracy of these measurements. Inside the research aircraft, we have different systems. The first one, M300 data acquisition system, which is basically took all the measurement as a raw data from all instruments and presented to the flight scientist within the research aircraft. We have VHF communication radio in order to coordinate between the ground operations center and the flight scientist within the research aircraft. So this is very helpful in order to make the decision whether we should change the altitude or change basically the line of sampling of this data. We have also onboard navigation system. it shows us the image of the radar of the cloud seeding aircraft positions, as well as the research aircraft positions. So the kingdom have different intensive operation periods. What I mean by intensive operation period, basically this period is established to use this research aircraft to collect cloud samples and aerosol particles. We did the first one, IOB1. We did the second one, and we plan right now to do the third one. The SARBIC, or let's say the Saudi Aerosol Cloud Precipitation Enhancement Campaign, SARBIC Research Roadmap, objectives is to build a cloud climatology of actively growing convective clouds, establish the level that supercooled liquid water exists, and analyze data at different levels above cloud base to determine how liquid water content changes with increasing the height or altitude, with increasing the altitude and decreasing the temperature. So after collecting these data, we aim to use it and integrate it with the WRF models, numerical prediction models, as well as artificial intelligence and machine learning algorithms, in the help with using some remote sensing such as satellite data and radar data. The first IOP, intensive operation period, which is occurred in late summer 2023 in the southwest region of Saudi Arabia. We covered almost 39 research mission hours, starting from 30 July 2023 up to 16 August 2023. So this is basically the flight track of the research aircraft in the southwest region of Saudi Arabia. We covered almost 3 cities, Mecca, Abaha, and Asir. The second intensive operation period, which is IOP2, it occurred in the fall of 2023 and covered the central region, mainly in Riyadh, Ha'il, and Qasim, from 21 October up to 23 November, with almost 72 research missions hours. So as you can see here, this is the track flights of the research aircraft in the central region of Saudi Arabia. IOP3, which will occur almost in this year, 2024, and it's planned to starting from 15th of March up to 26 April, with almost 67 research mission hours planned. We are welcoming in IOP4 to invite discussions on potential collaborations, as long as it's centered around the utilization of research aircraft aiming to enhance the Saudi Green Initiative and sustainability efforts in line with the Vision 2023 frameworks or 2030 visions. So after collecting all these data from our intensive operation period, our team participated in the annual meeting of the American Meteorological Society, which is placed in USA, with different research papers and findings. This is one of the findings, as you can see. So this paper is cloud observation and process in sea breeze-induced convection over southwest Saudi Arabia. So as you can see, this measurement took place in Abha from the 5th of August, 10th of August, and 13. So we're focusing more on the data we have been collected using the advanced instruments I've explained it above. So as you can see in the right figure, we focused almost in the droplet concentration using the cloud to droplet probe, which is used to measure the cloud to droplet size distribution. As long as we have 3 samples, as we can see in the figure, we have 2 samples which is almost has fixed droplet concentration side. So when we focused more in the effective radius, we observed that the effective radius is increased. So as long as it increased, this cloud is suitable to do cloud seeding. However, you can see in the green sample, the droplet concentration is decreased almost from 600 to 400, with increasing with the effective radius in the figure above. So this cloud, it's already raining, so it is not suitable to do cloud seeding. This is one of the findings that we have did as a research work from these operations period. So thank you so much.
Thank you, Asma. Engineer Ayman Albir, Executive Director of Regional Cloud Seeding Center Program, I would say.
So we are back. Sorry for that. I'm so delighted to be part of this conference hosted by our colleagues in the Regional Desk Center, and I'm glad for this opportunity to give an overview about the Regional Cloud Seeding Program. And okay, this is an overview about the presentation. Just to give an overview about the precipitation annually accumulated over the globals, Saudi Arabia, it's an arid to semi-arid area. We have received less than 40 millimeter in comparison to the remaining countries which exceed 2,000 millimeter. Even by redistribute the rainfall average, it doesn't exceed 200 millimeter over the mountain area. In addition to the water demand challenges that we have in the Kingdom of Saudi Arabia, as an example, that we have a steady increase in the population of the kingdom with 140% during the last 30 years, from 13 million up to 32 million back to 2020. So weather modification or cloud seeding program, the concept of the weather modification is that through natural and man-made application, clouds can be modified to increase cloud and precipitation, decrease clouds, decrease or the occurrence of the hail. And the most scientifically justified approach by the World Meteorological Committee is the attempt to intervene in the cloud physics process through introduction of seeding materials, which is aerosols. Worldwide experience in the cloud seeding, according to WMO, 52 or more countries have a cloud seeding program performed with the different companies, and part of this is Saudi Arabia. This is an overview about the history of the cloud seeding in the Kingdom of the Saudi Arabia. The first idea oriented back to 1976, and the first seeding experimental, it's back to 1986. The first project was back to 2004 at Asir, followed by another project to the central region. This project completed back to 2008. And today, we have the Regional Cloud Seeding Program is one of the outcome of the MGI, Middle East Green Initiative Summit, announced by Crown Prince Mohammed bin Salman 2 years ago in accordance with the Kingdom's Vision 2030. In addition to the Sand and Dust Storm Warning Regional Center and the Climate Change Center. The mission of the program is to design and execute state-of-art cloud seeding mission using cutting-edge technologies to establish NCM as a major weather modification service provider for the region. The vision of the program, to take an advantage of technical and scientific achievement to design and execute cloud seeding projects that will enhance rain amount and contribute to effort for the restoration of the ecosystem to create a more sustainable future for the region. The duration of the first phase is 5 years. Program starts back to 22 as an SGI with a national coverage. The main goals of this program is to increase the precipitation rate between 10 to 20%, transfer the knowledge, and to contribute to the cloud physics research and mesoscale atmospheric, and to participate in achieving the goals of the Green Saudi Initiative, contribute to mitigate the climate change impact, and contribute to reduce the desertification effect. The methodology of the program is going with the 4 main pillars: research, evaluation, preparation, and implementation. And this is like an ongoing lesson. As much as we having a research activities result, we evaluate the outcome and rephrase our implementation plan. Area of focus, mainly we have 2 areas to focus on this program. Research, which is related to studies and research with the aim to continuously evaluating the effectiveness of cloud seeding operation. And the second area is the operation itself, which is concerned with the technical and operational aspect of the program, from implementation of cloud seeding experiment with a targeted technology, measuring the impact of the experiment and knowledge transfer and qualifying efforts. Preparation plan in such program, it has different elements: long-term, mid-term, and short-term. Whenever we are talking about long-term, it's talking about the climate projection and the climate outlook, utilizing the modeling that we have, in addition of the infrastructure of the radars and the surface observation. The second level, which is the mid-range, utilizing all of the weekly forecast of the targeted area up to the level of the operation. To execute such mission, we need to have a huge monitoring system and station, and this is an example of what we are utilizing. All of the infrastructure that we have it within LCM, from number of monitoring station, aircraft, database, mobile station, radars, in addition to the climate and the weather models. These are just an example of the climate weather model and the special model that it's been used in a daily use to execute the operation or to evaluate and to assist the outcome. This is an overview about the progress during the last 2 years. In terms of operation, this is just an distribution of the rate over the region of the Saudi Arabia. Also, we achieved 1,300 flight hours, in addition to 111 hours as a research flight, covering several regions of Saudi Arabia. And we conduct more than 415 missions, in addition to 36 missions as a research activity. And this is part of the progress that we have it for the research activities. This is one of the activities that we are working now on it, and it's a pleasure to share some of this information. One of them, the sensitivity test on a real seeding scenarios based on the RAMS-ICLAMS modeling system for one of the cases that it has been measured utilizing a research aircraft and the cloud seeding mission. And if you could see that, the first image is showing the normal process without adding any seeding material. In the second one, you could observe that there is an increase of the rainfall precipitation, and the difference, all of the red colors are showing the positive increase over this observation by 40%. This is another example of the studies on an effort that we are doing to evaluate the progress in the program, precipitation climatology across Saudi Arabia based on graded data during cloud seeding period, and the reanalysis data and the rain gauges, both of them are showing a positive impact on the rainfall. This is another one, assessment of rainfall in the Kingdom of Saudi Arabia utilizing pre-post analysis. And it shows during the seeding period, either 1 or 2, a positive result, and still we are working to collect further information and data to evaluate such assessment. And cloud observation and process in a sea breeze ensued convection over southwest of Saudi Arabia. It's part of this assessment. It's already been covered by ASMA presentation. Sensitivity of a deep convection in southwest of Saudi Arabia to ice nuclei concentration utilizing a cloud resolving model. And it shows us that we are advancing the time of the cloud formation process by almost 30%. And if you could notice that in the below paragraph also, we are increasing the total of ice nucleation during the time of the seeding. Verification of the cloud seeding utilizing a radar. Also, we are utilizing the radar data, and you could see in that from the first graph, the red color is showing the cut of the time when we start to seed the cloud, and all of the parameterization analysis from the radar is showing a positive result, either in the total volume of the water or in the reflectivity. Moreover, still we are working to measure the effect of the cloud seeding operation through the satellite visualization, and more than 97% of the mission is showing a positive impact through the satellite image. This is another area we are measuring the effect of the cloud seeding through the vegetation cover. This is one of the examples where it shows Al-Baha. There is an increase from 100% kilometer to 800. Effect on the observation through the dust observation. In a collaboration with the dust center, we also working to do a comparison between the rainfall observation against the dust to verify the collaboration and the efforts in such area. Also, we are measuring the media photo on a specific area where we are seeding the cloud to capture the impact in reality utilizing media image. This is also one of the efforts that we are working on it now. It's a cloud seeding predictive decision support system using an artificial intelligence model. And from the first run, it shows remarkable matching accuracy up to 93%. Future research and action plan. Still, we are working. This is the first year of the research activities. And there is a list of items that we are working now and looking to do it in the near future. As an example, simulation study of physical and chemical and dynamical process during cloud seeding with very high resolution models. Economical and environmental impact of the program to the region. Exploring advances in nowcasting simulation. Calculating the ZR relationship using radar data for the region. Implementing new cloud seeding technologies, research on procedure and data collection during operation to improve cloud seeding efficiency. And we are working to establish a research activity between the program and Sand and Dust Storm Warning Center, exploring further effect of the rainfall enhancement to dust and dust even. Study possible influence for the weather modification to regional climate characteristics with our colleagues in the Climate Change Center, work to establish maximum possible collaboration with the countries that run cloud seeding program in the region, strengthen our presence in WMO Weather Modification Scientific Group. The future operation plan we are expanding our work to the northwest and northeast side of the kingdom to discover more opportunities to seed the cloud over this area. In comparison to the climate report that we are working on, there will be a good potential in these two areas. This is a summary. The Kingdom of Saudi Arabia has made a great effort to protect the environment and reduce the effect of climate change, and has sought and implement unique initiative to confront the environmental challenge in the kingdom. Cloud seeding technique are one of the opportunities available, and we gather at this conference to join forces and coordinating our efforts to protect the environment, confront climate change, and develop a roadmap toward reducing carbon emission in the region. With this, I will conclude my presentation. Thank you.
Thank you, Ayman. Our next speaker is Dr. Manish Kumar. He is the director of the Research and Development Center for Environment and Energy Development in India, and he leads the interdisciplinary research on ambient air quality, energy transition, and climate change issues in India and South Asia. Please.
Thank you, Professor. Good afternoon, everyone. I'm Manish. Okay. So, as Professor Stanchikov highlighted, that the dust accumulation or the dust deposition is constantly increasing, and the two previous speakers before me have highlighted that the need for cloud seeding programs and adopting more greenery-oriented projects in the area. While these steps could take some time, this could be possible after a certain period of time, like 5 years or 10 years, we will see the actual outcomes. I would like to talk some of the market-driven approach that can be helpful in solving this problem immediately. So, the entire world, be it whatever geography it is serious about climate actions. It is serious about carbon neutrality. It is serious about decarbonization. The efforts could be different. Efforts could be more or less based on the economy of the country or economy of the geography. But there is no doubt that we need some accelerated climate actions. And if we see the different elements of climate actions towards the reduction of the greenhouse gases, we see there are some points like transition to cleaner and low carbon energy systems. Similarly, to systematically reduce dependency on fossil fuels. In the last COP, some of the countries, including India and also the oil exporting countries, have clearly said that we are not thinking about phase down of fossil fuels or phasing out of the fossil fuel right now, but parallelly we will be developing the renewable infrastructure so that the dependency on fossil fuels will be reduced in time. Similarly, promotion of nature-based solution for carbon sequestration projects. Cloud seeding could be helping in that. And similarly, there are carbon capture, utilization, and storage projects going on throughout the world. So if we try to understand the sectoral contributions of greenhouse gases, we see it is the energy sector which is contributing to the majority of the greenhouse gases around the world. And out of those energy sectors, basically the energy used in industries, energy used in road transport, and energy used in buildings for domestic consumption. So if we try to see the global energy mix, it is mostly dominated by fossil fuels. Coal 28%, oil 30%, natural gas 22%. In some of the geographies, like I come from one of the eastern Indian states of India, where the energy mix is dominated by coal up to 95 to 96%. In such a scenario, achieving climate goals, achieving climate neutrality will definitely be depending on how we are going to scale up our renewable energy systems. So, if we talk about the exact roles of renewable energy in reducing carbon footprint, it can be used as a clean alternative. It can help in mitigating climate change through decentralized projects, decentralization of the energy systems. It will also help in job creation and economic opportunities in the region. And similarly, there are some challenges and barriers in adopting clean energy as well. We will discuss a couple of them now. And we also need some technological advancements and cost cutting for scaling up of those projects. So if we try to understand the renewable energy usage currently and the potentials throughout the globe and also to the specific geographies like Middle East and African region, so we can clearly see that the renewable energy share is increasing in almost most of the region because of the sensitization levels are increasing attributed to the impacts of climate change in various regions. So if you try to understand the solar potential, because we are mostly talking about dust deposition and dust storms here, so I am emphasizing the solar potential in different regions. So we can see that the Middle East and North Africa region has a huge solar potential that can be harvested for driving clean energy and decarbonization efforts. Similarly in Saudi Arabia as well. However, the share of renewable energy sources is still lesser because probably it is still growing. So now if we're talking about renewables, if you're talking about solar PV cells, as Professor Stanchikov suggested, he explained that there are different types of particles, they are having different behaviors on soiling of the solar panels or reducing its efficiency because of size and different parameters. So there are two different mechanisms. One either through the dust outbreaks or the deposition of the dust directly on the solar panels. At the same time, geographies like northern part of India or the Indo-Gangetic plain, where there is a huge haze, dense haze-like conditions that also block the solar radiation coming on the solar panels. So these are some of the challenges in scaling up of renewable energy, specifically the solar one, and the energy losses due to this soiling process could be as high as, could range from 4 to 20%. There are some published papers which suggest that it could be even higher as 40% in some of the regions in Africa. So if we try to understand the different mechanisms, so most of the mechanism is driven by the climatic factors, be it soil property, wind speed, scavenging properties, transport of dust, temperature, and there are lists of different processes, atmospheric processes, which affect, as we saw in the formula used, shown by Professor. So what could be the immediate step? As I was saying that cloud seeding programs or greenery enhancing programs will take time. So what could be the immediate solution? An immediate solution could be cleaning them. Let us clean and then get rid of the soil, get rid of the dust deposited on the solar panels. So there could be different methods. For example, water, cleaning by water, electrostatic methods, some mechanical methods like brushing, air blowing, and ultrasonic vibration. Also, there are certain innovative methods which are also having a lot of potentials. For example, we don't need to clean them. There should be some nanomaterial coating on the surface of the solar panel so that the deposition could drive away automatically. The methods, some of the methods could be, for example, water cleaning is generally criticized because it uses water and it has an additional carbon footprint. However, if we try to understand the different geographies, their economy, We are not in a position to say which method is good, which method is bad, but of course we need to plan it in advance. We need to be future ready to understand that what method can work in which type of geography and which type of economy. So if we try to understand from market point of view, because we can do everything, we have potential to do everything, but we need money, we need markets, we need scaling up of the important products that can help in cleaning of the solar panels or decarbonization efforts. So if we try to understand the market drivers of the market for these cleaners, no matter what cleaners, so high demand for installation, because in the entire world solar installations infrastructure is increasing. Similarly, everyone wants best efficiency of their solar panels, and there are different environmental factors affecting time to time, causing reduction in the efficiency. As I said, the constraints, the cost is the number one constraint. We need to think about the money, we need to think about the investments coming for those types of efforts, and also water footprint in some of the regions like where we are standing, where we are sitting now. So water could be, availability of water could be another challenge. Similarly, accessibility and safety. I see in India there are very many narrow streets, the houses are very close to each other. In solar rooftop installations are so complex that it is very difficult to go and climb up to the terrace and clean the solar panels. So this could be another challenge. However, we have some opportunities that we have now AI, we have a lot of technological advancements that can be adopted to achieve these goals. And similarly, the best opportunity is the market is emerging. So we have observed some of the reasons with increasing investments in solar panel cleaning systems. So if we see the market, the current average growth rate is almost close to 10%. With this rate, the current market size is almost 1 billion US dollar. That will be increasing up to $2.28 billion by the end of 2029. So if we try to understand the market share of these cleaners, different technology-driven cleaning systems for solar panels, still we can find that North America is still having a lot of share in these cleaning devices. If we talk about those regions which are having frequent dust storms or having more problems like this, what we are talking now, like the MENA region, it is still having very low share in the market regarding the cleaning systems are concerned. However, the reason is pretty clear that we have lesser installations, so that is why cleaning systems, the market share is lesser. However, with time, as we get future ready with the more and more renewable installations in the future, definitely this market share will be increasing. And if we try to, some of the projections suggest that the application of these solar panel cleaning systems are increasing in all of the categories like residential, commercial, and industrial. So the most important thing which I would like to discuss, I work on energy modeling systems for in a high resolution using some open access models like PyPSA. We are trying to understand that what will be the energy load after 20 years, after 50 years. India has committed its net zero ambition by 2070, so it is very important to understand that what will be the energy load, what will be the energy demand, and what will be the climatic situation after 10 years, 20 years, or 50 years, so that we can plan our energy systems. Hence, I firmly believe that the climate modelers and energy modelers should work together to understand this problem, whether we are able to forecast or whether we are able to model the future scenarios, that how will be the infrastructure on renewables will look like after certain years, after 50 years. And another important aspect is localized planning and technology development is more important. Last week, Government of India has launched its scheme that they will be offering 10 billion solar rooftops in the entire India. as a solar above their terrace, house terrace. So this could be an important step where cleanings could be relatively easier. Deposition of dust could be relatively easier because they are decentralized. They don't need any big system to clean them or to get the maximum efficiency. And similarly, as I said, money is the most important thing. An institutional framework for investment in all possible ways of dust reduction and solar PV cleaning systems is required, be it in Africa or in Middle East or in any part of the world. And some of the speakers were also suggesting day before yesterday on a regional cooperation for the solution of this problem, whether dust management or cleaning of the solar panels or in improving the efficiency by any means. Additionally, it should be linked to the job creation, employment opportunities, and it should take care of the fact that the society should be in the center. This is the time. This is not much research have been done so far on all these aspects, but this is the time we should be future ready. We should be forward looking so that decarbonization goals can be achieved for all kind of geographies, all countries, and climate actions can be accelerated. With this, I would like to thank you.
Thank you, Manish. So, our next speaker today is Dr. Zakia Al-Harji. She is a climate research scientist in the NCM, National Center for Meteorology, in SDS WAS Center. She will be talking about frequency of haboops in Riyadh.
Thank you, Professor. Good afternoon, everyone. Assalamu alaikum. I need to talk today about spatial and temporal variation of precipitation and dust storm event in Riyadh, related from seat observation. Yeah, if you're looking for the graph, you see I compare between 2 years. One year it's 2018 and second years it is 2023. If you see the amount of rain, it is almost it's biggest amount and the great amount of rainfall in these 2 years. But if you're comparing, we say increasing in the amount of rainfall in 2023. It is in 2018, it is around 108 millimeters, and in 2023-30, it is around 147 millimeters. But we see it is the biggest issue here in front of us. It is increased the dust storm. Increased dust storm in 2018, it is around 297 events. But we see right now that still the increased amount of rainfall in the 2023, but still reduce the dust storm. We need to ask right now today to answer about the question. The biggest question in front of us today, why we have less sand and dust storm on 2030 comparing to 2018 in Riyadh, while both the year have almost the same amount of rainfall. I need to talk a little bit about what I used about the statistical and analyzing the observed dust storm event in the year 2018 and 2018 and 2023. We are analyzing about the regression analyzing about associated coefficients of determine R square and model, and certainly we consider to evaluate to see what is the element from weather to become the fit with the or reduce it or impact with the dust storm. And also we use the Pearson correlation coefficient to analyze. We use it to investigating the positional existence of two significant correlation between the precipitation and the frequency of dust storm occurrence. Right now we talk about that dust and thunderstorm from where I take the data and what is the criteria. We take the data we use the meter data from NCM and we use the criteria from the WMO. This criteria, we should to focus about wind speed. They show to wind speed it is high than 22 kilometers per hour. And also, we focus about, when analyzing the data, about feasibility. We should the feasibility, it is reduced below 5 kilometers. And also, we focus about the code weather. We use some code from the dust event. We focus about the dust storm and dust and sandstorm, and the blowing sand and the blowing dust. And right now, we see, if you're comparing between this 2 years, 2018 and 2023, we see the amount of rainfall. It is in this both of the year, it is increased. As I said before, 2018, it is gets the amount of rainfall around 180 millimeters, but still the dust storm events are around 297 events. If you're comparing with the 2023, we see it is more high, the amount of rainfall, but reduced the dust storm, which is getting around 47 events. And right now we needed to see why you get this amount reduced in 2023 than the 2018. We see the season here for dust storm in Riyadh. The season, it is in the spring and summer season. And we see it is the season increase amount of dust storm. But this is more increased in 2018 than 2023. And if you see it exactly about how many from the rice dust and dust storm and sandstorm, we see in 2018 it has got it around for rice dust around 76, and in 2023 we got it about 46 even. And also, if you're comparing with dust and sandstorm, in the 2018 we got a 21 dust event and dust sandstorm event, and also in the 2023 we got just one event from the dust storm. And we see here of the 4 years, I use this 4 years to see the season for the rainfall, from where it starts and from where the beginning. And if I focus about 2018, we see it is beginning in the end of the season for rainy season. And if you see also in the 2023, it is in beginning from the beginning of the season in a start and successful for every month to come the rainfall. And here right now we talk a little bit about wind. The prevailing wind in Riyadh in north and northeast and northwest and south and southeast. And annually for average for wind speed in Riyadh was about 10 kilometers per hour. And here we focus about these 2 years because this is my case study here. In 2018, I focus about the spring season and summer season to compare the direction and wind speed in Riyadh. In 2018, we see in spring the wind speed become fluctuates with the wind speed ranging between 11 kilometers per hour in March and April and May. If you contrast it with the summer season, from June to August, with the average wind speed around 4 kilometers hours. But here I find in the wind speed here, it is higher than 2023. If you see in 2023, in spring season, the wind speed fluctuates also with wind speed ring in 10 kilometers per hour in March to May. But if you contrast with summer season from June to August, the average wind speed around 10. It is like become the similar in the both of the season in spring and summer in 2023. And here, this is a graph show you from where start the season for the 2018. It is started from October. We take it the season in October 2017 to 2018. This has become the amount of the total for all the season, rainy season, around 120 millimeters. But this season started from the end of the season. If you're looking for April 28, we see the amount of rain almost around 44 millimeters, but still the dust storm increased around 37 events. And for this reason, the soil moisture become for dry and losses to particle for the soil. And for this reason also, after April, start the season for the summer and become that the temperature is high and also increase the wind speed. And for this reason, to become the dust storm event is here, it's very high. If you contrast them with the year 2023, we see it is start the season from October 2020 and until 2023, and the total for rainfall in this season are around 197 millimeters. And the season starts from the beginning, from January 2023. And they got it almost amount of rainfall around 80 millimeters, and become successfully the rainfall and follow up in every month in this season until May. After that, start the season summer. For this reason, become the sandust and sandstorm event reduced in this year. For this reason, because the rainfall got enough amount, and the soil moisture, it has become the woody and complex. And if you're looking here, I get from the mirror to show you for the season for the surface soil moisture. If you're looking in 2018, it has become the soil moisture is very dry, and the skull bar to show you the percentage. It has become between 0 to 2%. If you're comparing with other graph to show you the soil moisture between 1 to 4% in the skull bar, and become this soil moisture is like woody and complex for the soil. And here I choose like as example to show you, and every year have a dust storm. I choose from April in each this year. This is dust storm event come in 26 in April in 2018, and also I comparing with dust storm coming in last year in 28 in April. This both of dust storm get to the wind direction from northwest, and this is like become the similar situation in both this dust storm. But the reason behind the reduced dust storm here and not impact more for the soil moisture there, it has become very compact and very dry, very woody into 2023. And if you're looking there also in the first graph about the dust aerosol optical thickness in 2018 in April in the same event, we see it has become very thick and very high impact in all Peninsula, especially in Riyadh. If you're comparing with also the dust aerosol optical thickness in 2023, we see a little impact and not impact more than the last year. And also here we see the surface for PM 2.5. In 2018, it has become high impact here in all the Peninsula, and also we started from the Jordan to Iraq to Kuwait and so all the GCC. and especially in here in Riyadh. If you're comparing with surface PM 2.5, we see it little impact about the Al Peninsula here. And here it shows you this map for the wind speed here, and how come in that time for the April 2018 and also April in 2023 to show you the situation for the wind speed and from where direction for the wind here. And also here both the map to show you in the same month the average for rainfall in both of the year for the amount of the year. It has become the increasing in 2018, but not more impact than the last year. We see more impact about the rainfall in this area for become the soil moistures is become woody and complex. And also here I show you in the final how come the surface for soil moistures in the time for the dust storm or in the month in April in the both of the year. I show you if you see it in April 2018 it's become more dry, and the bar scale to show you it is percentage between 0 to 2. And also the second chart to show you the soil moistures, it has become between 1 to 4%. It has become here in soil moistures, it has become woody and complex for the soil. And here I show you the just image for the event for the dust storm. To see it is like become similar, and also for the direction of the wind speed here also become the similar, and the situation is similar. But the difference here about the soil, it has become woody, and also the precipitation become in the beginning of the season in last year, and become the follow-up for the whole month and get enough amount of rainfall, and for this reason become reduced dust and sandstorm in last year. Then in 2018 it has become the rainfall in the end of the season for rainy, and for this reason after that become summer season, and for this reason become the sand and dust storm increased because the soil moistures it is become like the dry, and that's all this condition less the sand and dust storm increased. In conclusion, the dust and sandstorm in Riyadh starts in the season for the dust and sandstorm in spring and summer, and in our study, we found that the highest frequency of dust and sandstorm occurrence and observed in May and August during the study period. There is a negative correlation between dust and sandstorm and precipitation. And the analysis of two distance period reveals variation of the timeline for the precipitation and their impact of sand and dust storm occurrence. And we're thinking in the finally, when the rainfall occurs in the beginning of the year or beginning of the season for rain, it has become, this is impact about reduce the dust and sandstorm events. And thank you. That's for today.
Thank you, Zakia. Our last speaker today is Dr. Ioannis Chiniotis. He is from National and Kapodistrian University of Athens, and he will be talking about modeling of the effect of dust on clouds, and evolution of clouds and precipitation.
Good afternoon, everyone. I'm Ioannis Chaniotis. I'm currently at the University of Athens, and I'm also affiliated with EPFL. My main research topic is the study of cloud aerosol interactions within clouds with the help of numerical modeling. And today I'll talk about the impacts of desert dust or some severe storm cases over northern Greece. The main motivation behind this work is to examine how these dust particles affect the cloud formation and cloud characteristics, the precipitation type and the amount, since precipitation has a very strong influence on human activities such as infrastructure, the economy, health, and so on. Dust is also known to have strong impacts on weather extremes, so more accurate weather predictions are vital. For this study, we've used the Integrated Community Limited Area Modeling System, or ICLAMS for short. This was developed by the University of Athens, and it was based on an older model, the Regional Atmospheric Modeling System, or RAMS, developed by the Colorado State University. This merger, RAMS-ICLAMS, includes the dust and sea salt production and transport in the atmosphere, as well as parameterizations for the cloud and ice nucleation processes of these particles. The main mechanism of dust production in the atmosphere is called the saltation bombardment, and it happens when the friction velocity exceeds a critical threshold, so large sand particles larger than 60 microns are ascended into the atmosphere for a brief amount of time, and then they hit the ground, and upon their breakup, they form smaller dust particles that are those that can eventually float for a longer time periods and can travel to hundreds, even thousands of kilometers. Ultimately, the dust flux is controlled by the wind speed close to the surface, and of course the surface characteristics, such as the vegetation, the soil type, and the soil moisture. And of course, the turbulence in the planetary boundary layer can control the mixing of dust to higher altitudes. In the model RAMS-ICLAMS, dust is partitioned in 8 bins, as shown in the on the upper right panel. One big question is how aerosol particles and especially dust impacts clouds. What is the current state of knowledge? As we all know, dust is in many complex interactions in the atmosphere. First of all, it interacts with radiation. It scatters shortwave radiation, absorbs and emits longwave radiation. This is called the direct effect of dust. And this is very important because it modifies the energy budget of the atmosphere vertically. Another effect is the semi-direct effect, which describes the phenomenon when a layer contains high amount of dust and absorbs radiation, it heats up quickly and forms a very stratified and stable layer, preventing convective phenomena. Furthermore, dust is known to have a very strong cloud condensation nuclei ability, CCN for short, which induces changes in the cloud hydrometers. For example, clouds with dust have smaller and more cloud droplets, which affects the cloud albedo, the cloud lifetime, as well as precipitation. It's worth mentioning that dust also have very strong ice nucleation properties, which can affect the mixed phase clouds. So, to summarize, the current state of knowledge is that dust may affect clouds by inhibiting the precipitation at the early stages of cloud formation, which may be followed by higher production at the mature stage. But when the dust concentration is too much or the available water content in the atmosphere is too low, precipitation is finally reduced. This is known as overseeding. In the model, the number of activated water droplets is calculated by the Foudoukhis, Nénès, and Seinfeld algorithm, also known as FNS. It is based on the classical Keller theory of cloud nucleation and takes into account the dust size as well as its chemical composition and crystal structure. Also, some other basic meteorological parameters, such as the pressure, the temperature, the humidity, and the vertical motions in the atmosphere are also taken into account. The hydrometeors that are resolved in the model, the RAM cyclams, is the cloud and rain liquid droplets, the pristine ice crystals, the snow, and aggregate crystals, which are considered solid, and lastly, Groppel and shale, which is considered mixed phase. All these models follow a generalized gamma distribution with predefined parameters, which come from semi-empirical results. But eventually, the hydrometeor properties, such as the mixing ratio, the diameter, and the number concentration, can be either full prognostic or static in the model run. For this case, we have selected 3 particular events of extreme rainfall and extreme events over northern Greece. These events, as I mentioned before, share heavy rainfall, strong wind gusts, and hailfall, with the presence of desert dust in the middle and upper atmosphere. And as you can see on the left panels, this is the dust loads retrieved from the model simulations. Dust originated for all these 3 cases from the Western Sahara, and with the help of southwestern and western winds in the middle troposphere, dust was transported to central and eastern Mediterranean. It's worth mentioning that the cut-off lows, troughs, and frontal activity over the western Mediterranean may enhance the dust transport eastward. Now I would like to follow with a brief discussion about the model setup. The ERA5 reanalysis dataset was used for the model initialization and boundary conditions. Dust was considered a prognostic aerosol, meaning that its properties were calculated dynamically and they changed by the conservation laws. Its interactions with radiation were coupled with the RRTM model and the microphysics with the Fontouchis-Nene-Seinfeld algorithm. For each case, 2 simulations were performed, considering the dust effects and without considering the dust effects, namely dust and no dust. And 3 nested domains were used, as shown on the right panel, with the resolutions of 24, 6, and 2 kilometers. So the big question is how dust eventually affected all these 3 cases. On the left panels, we have the accumulated precipitation over the area of interest, which is northern Greece. And on the right, for the no dust, of course, case. And on the right panels, we have the differences from the dust minus the no dust case. For the first 2 cases, sorry about that. For the first 2 cases, there were sparse storms scattered across the model domain, while for the 3rd case, precipitation was much more spread because the event was much more stronger. For the first case, the changes in the precipitation patterns induced by dust are insignificant. It's less than 2%. On the second case, the changes are stronger at about 10%. And lastly, on the 3rd case, these changes exceed 20% in the spatial distribution. Another way of comparing for each case the impact of dust is to plot the quantile plots for the dust and no dust scenario of the rainfall rates on the upper panels and the hailfall rates at the bottom panels. The x-axis represents the rates of the dust scenario, and the y-axis represents the rates of the no dust scenario. And as we can tell, for the first case, there was no significant change on the relative distribution of the rainfall rates. But on the second case, there's an evident rain suppression in the dust scenario, since these values are under-predicted because they lie on the left side of the y equals x line. On the third case, the results are more interesting since dust seems to contribute both to increased rain rates and hail rates. By comparing the time series of the average rainfall rate across the whole domain, again, we see no significant changes for the first case. But on the second case, we see during midday a relative reduction of rainfall rates for up to 15%, the maximum difference. On the last case, which was the more interesting event, the dust contributed to higher rainfall rates, even exceeding 15%. Similar results can be drawn by comparing the hailfall rates, time series. On the first case, we have a reduction of hailfall rate by up to 60% during a narrow slice of time during midday. In the second case, and during the first stages of storm development, dust suppresses hailfall, but enhances it on the latter stages. Lastly, on the third case, hailfall is significantly enhanced by over 100% in the first and later stages of this event. And there's also evident a time lag of up to close to 1.5 hours. By comparing now the total rainfall across the whole domain, for the first case there are no significant changes. These E values refer to the relative changes from the dust minus the no dust scenario, to be clear. For the second case, there is a reduction of close to 2% in the dust scenario of total rainfall. And on the third case, there is an increment of close to 9% in the dust scenario. In the total, by comparing now the total hailfall, there is a decrease of close to 4% in the first case, insignificant changes in the second case, and 57% increment on the last case. What can we also conclude by examining the relative changes in the average properties of cloud hydrometeors for these cases is that the pristine ice and hail particle production was significantly favored in the last case. And as you can see by the indices, we had an 11% increment of pristine ice crystal number concentration and 3% increment of mixing ratio. And rain droplet diameter and mixing ratio was also increased, while number concentration was reduced in this case, in the third case. So the take-home messages from this study is that dust particles indeed affect the cloud formation and precipitation production, since they are effective CCN and IN particles. I would like to mention again that the ice nucleation properties of dust are very predominant, especially on the third case that I showed earlier. Dust induces changes in hydrometeor characteristics, which in turn give spatiotemporal shifts in the precipitation patterns. And their complex interactions in the atmosphere may have significant different outcomes per case based on the state of the atmosphere and the available content of water vapor. And I would like to thank you at this point. Salam alaikum.
Thank you, Ioannis. Audience, please show your questions. Yeah.
Thank you for the informative information. I have a question related to cloud seeding. Have you involved the weather conditions during the rainfall situation, such as, is it baroclinic instability or frontal systems? And what are the criteria behind choosing the sites of the tested regions that you showed in your presentation? And I have a comment also related to the electrostatic method for removing dust from the panels. can we use this method to capture or trap the dust before it reach the solar panels or before reaching the cities as trappers? Thank you.
So, that was a very interesting question. I've selected these three distinct cases because the meteorological conditions are relatively different. The first case was a shortwave and shallow trough passing through northern Greece, which is a common characteristic, a common climatic characteristic during summertime. And with the guidance of, with the transport of dust can induce such phenomena in the region. The second case was a more organized system, but again it was a result of a cut-off low. The third case was a cold intrusion in the region that resulted in the development of a supercell in northern Greece. That's why I selected these cases. The region is of interest because it is affected during summertime by intense hailfall that affects negatively the crops in this area. So, as it was mentioned in the conference earlier, there's a program ongoing that tries to reduce the effects of the formation of hail in this region. Did I cover your question? Have I forgotten something?
Yes, but sorry for a misunderstanding. My question was about the Saudi program for cloud seeding.
Yes.
Sorry for misunderstanding.
Thank you for your question. So regarding the regional cloud seeding program and the decision making for the suitable cloud, there are many criteria we are working on. So such as a convective day category. So convective day category is a criteria to make this decision based on the radar heights and also the satellite images and precipitation estimations. Right now, we are working also in developing a machine learning algorithm based on stability index from the weather conditions measurements such as WRF and numerical weather prediction to help us make this decision. So I have answered your question.
Thank you very much. This is Abdul Majid Haddad from United Nations Environment Program. Actually, I have 3 questions. Am I allowed for 3 questions? Very quick. The first one is actually building on what my colleague from Iraq was asking about the criteria, but I'm really very interested in to know why Abha and Asir region was included in the intensive operation sites, because they receive more rainfall than other areas. This is the first part of my question. The second is for Dr. Ayman, the regional center. What is the plan for expansion? Are you going to expand north, east, or south of the Arabian Peninsula of Saudi Arabia? So, what is the regional scope of the center? In other words, my last question is to Ms. Zakiya, and it's about the comparison between 2018 and 2023. I think it would have been useful if you take averages of more than 1 year and compare them. The second is to include other parameters, because we heard, for example, in the presentation yesterday that because of vegetation cover increase, there was a reduction in the dust storm, sand and dust storm. The second is that the source of dust for Riyadh, is it local or is it transboundary from outside? If it is transboundary, the dust, for example, I think you need to include a larger climate system to understand, the rainfall pattern
and the impact of this from the source area on Riyadh? Thank you very much.
Okay, thank you for the question. Let's take it one by one. The first question about the southern part of the Saudi Arabia and why we are targeting the southwest of Saudi Arabia. First of all is the frequency of the cloud formation of the area. It's much higher to comparison to any different region. So you will have a chance to conduct a certain level of operation or mission over the area. Moreover, the trend or the climate of the area back to 50 years ago, today if you compare, let's say, the mountain area Abha to the central region, it's look like that it's a rainy area comparing to Riyadh. But if you compare the area to the historical record that we have it 50 years ago or something before, it shows the trend that the area does not receive that much of rainfall in comparison to what they used to have 50 years ago. So even today, the mountain area or the southern part of Saudi Arabia does not receive that much of the rainfall in comparison to the historical data that we have. And it's one of the targeted area, and this gives us more opportunity to make a comparison between the convection of the cloud formation in comparison to systematic or seismic situation where you have a traveling pressure over mainly central to the northern area of Saudi Arabia. The expansion plan, our target today is to, by 27, is to cover the whole kingdom of Saudi Arabia as an infrastructure, as an operation plan. And later on, we will rely on the climate report to focus on a specific area with a period. Today, only 2 areas with the limitation that we have, and we are expanding our infrastructure. And as mentioned in the presentation, the first 2 areas that we are working now to expand infrastructure, either radar analysis or an antenna for the communication or a pilot or a crew. It's a huge infrastructure, so it will be the northeast and northwest based on the potential analysis that we have received from the climate department.
Thank you. Zakir.
Thank you very much, Dr. Gorgey. Now I'd like to invite His Excellency Dr. Jamal Al-Gahtani, the Executive Director of WMO, to the stage to honor...
didn't finish yet. Let Zakir to respond to the question, and I have one more question.
Because we're out of time, so we need to...
So let's wait 5 minutes. Zakir, please.
Yeah. Your question about if the Riyadh, it has become the impact about the dust and sandstorm from the different region or local. Yeah, we are present what I show you on the image, it is about the different region. It is impact about from Jordan to Iraq to Kuwait and all the GCC and Ben Salah. And this has become transfer from region to region, but also we have the local impact from the source from the north Riyadh and also in the south Riyadh. The second part from your question, why we don't right now, I present more deeply about other elements like wind speed and the temperature. Yeah, right now just we need to answer about why the dust storm it is reduced in last year than before in the historic period, which was just 2 years to study this question very deeply. And after that, right now we started to organize the paper about the all elements for climate, like temperature and wind speed, and also feasibility and rainfall together. And after that, we will publish this paper and we give you the result about the all elements.
Thank you. Last questions, please.
May I ask here or somewhere else?
Okay.
Thank you. First, I would like to thank all the presenters for excellent presentation, particularly Mr. Ayman and Ms. Asma for updating us on the weather modification program started in Saudi Arabia.
and I think we are so happy to hear the progress has been achieved. My understanding is the key objective of this center is to extend the vegetation cover, which is really multi-benefits for Saudi Arabia and in the future for the entire region. But I wish also if you can explore the possibility of the contribution of such a program for the recharging of the groundwater aquifer in Saudi Arabia. This is one. Number two, whether you have tested this, the extension of the vegetation cover, whether it is also considered the source of the dust in Saudi Arabia, because this is a critical area where we would like to see the coverage, vegetation coverage is coming. Last one, and I'm quite sure Mr. Ayman is aware, with the program of Emirates on the cloud seeding, and the progress has been achieved on a number of tracks. I wish also to hear from you about how much you have benefited from the output of the research have been conducted by UAE. Thank you so much for this.
Okay.
It's not on. Yep.
Okay. Thank you for the question. Yeah, I totally agree with you. The groundwater is part of our target, and we start a collaboration with the water sector to measure the groundwater using flow meters that they have it over different gauges just to capture it. And there is an area of collaboration to utilize the satellite image to measure the impact over the groundwater with a certain level of channels. And yeah, this is one of the research areas that we are looking for. For the dust, we are working on the soil characteristics relation or comparison to the rainfall impact on the soil characteristic utilizing certain level of the satellite channels. Also, this will avail us to understand more the impact and the effect on such area, especially with the conference and what we are looking for, and where we are all part of the SGI initiative, and they are working for the vegetation. For the achievement that what has been achieved, this is the first year for the research activities, and what we have presented is just an initial work, and just to share the information and the result as, let's say, just an initial work to highlight the efforts. And still we are working, and I think by the time that we collect more data, it will raise the level of the confidence about the conclusion that we have.
Thank you, Dr. Ayman. Our WMO, so participants have few questions,
well,
please.
Thank you. Of course, we can discuss later on the details. Just my question to Your Highness. It's nice study and really good progress. But my question is that not always implementation of models are improving modeling capability, especially for indirect effects. We started this work and tried to do comparison with Professor George Callas that time in our Yom-Chem cost action. That time it was not enough observation data. Later on, WMO Vigny group make comparison of 5 main models with indirect effects. And comparison shows what not only very different results, but sometimes signal due to aerosol impact on clouds are in opposite direction, because many mechanisms are comparing. And it is very important, I think, to do intercomparison with other models, and also, of course, the most important, to analyze and compare with observation, and not just simple observation, but also specifically measuring campaigns. Did you try to do
it? Thank you for your comment. As you stated, indeed, the effects of dust can indeed go in both directions. What I need to do from a modeling perspective is to examine the timing of dust and the interaction with the geometry of the cloud. For example, if the dust was close to the updraft, or if the dust was in the cold pool and it was washed away, for example. What I haven't, for the time being, I haven't done any comparison with real-time observations. But if I want to proceed with this research, it's a must. Thank you.
Anna.
سؤال هنا.
Thank you. First, I want to thank the scientists which spoke here in the name of the newly established GCC Center from WMO Warning Advisory System. And we already saw new and very good analysis with a highly systematic approach. My question is, my two questions are very simple, and they're for Dr. Aladji. Yeah, something. Sorry, still learning to pronounce correctly. How do you count dust storms? You said cases of dust storms. Is it days with dust storms, or there is some other method? And we saw highly variable precipitation amounts. And I just want to ask, what is the nature of these precipitation events? We saw monthly values. Are those extreme precipitations which happen during a day or two, or these are moderate precipitations which last longer time, because it's important because of the infiltration and soil moisture? Thank you.
About the dust and sandstorm events, about the event, we take it the all hours from the meters data for the whole year. We collected for each month the dust storm, how many hours record for each station. But exactly in this study, we focus just on Riyadh. We collect all record for hours in meter during the both of the year. And I present also the 2017 and 2022 to see the season from where to beginning the dust storm and from where the end of the dust storm. And also for precipitation, can you repeat please your question again?
Thank you. Sorry, we have to stop on this.
Just 30 seconds. Are there short-term precipitation happening in day or two, your high convective activity, or they are more like moderate precipitation precipitated in 5 or 7 days during the month?
Yeah. This is, as I show you, the season, from where to start in the Riyadh. It starts from in October to May, of the end of the spring. And I think the every day, not every day, the most of the month record around the amount of bar millimeters. For example, if you see in 2023, it is recorded in January around 80 millimeters for the amount of rainfall. We see it about the amount for millimeters, not see about how many days in this studies. I hope to get. Okay.
سؤال في الخلف عفوا.
Sorry, we have to stop at this. So please come here and ask directly the questions. Okay. So very last question.
Thank you very much. Most of times, precipitation mass or precipitation system originated from Red Sea and move over Saudi Arabia and Iran and reach to north and east of Iran. I have a question. Does cloud seeding cause to reduce precipitation portion other regions?
Do you mean if you intercept precipitation, so the moisture flux from Red Sea, will it reduce the precipitation in other regions? This is the question. No. Is this the question? So of course, if you take so part of the moisture on the way somewhere, so you will decrease probability of precipitation in this place. There were even how to say so court discussion in Australia when they use so cloud seeding. So there was less precipitation on the neighboring fields. So that we will compete for the same resource. So that will be the story. Thank you. Thank you everybody for the questions. We have to adjourn.
عفوا رئيس الجلسة سؤال هنا في الخلف من فضلك.
Thank you very much, Dr. Sajay. Now I would like to invite Dr. Jam'an Al-Qahtani, the Executive Director of WMO, to the stage to honor the chairman and the speakers, starting with the chairman, Gorgey Stanlakovic. Dr. Engineer Ayman Al-Bar. Engineer Asma Sarruji. Dr. Manashi Kumar. Dr. Zakiya Al-Haji. And last but not least, Dr. Lawanis Chantwitis. I'd like to thank the speakers for attending this session, and thank you for their contribution as well. We'll take a 15 minutes break and we shall be back for the last session followed by the recommendations. So please enjoy your break and see you in 15 minutes. اسمها سارة بصرات. قلت تركي يقفل جواله يا اخوي ازعجنا. قلت تركي يقفل جواله ازعجنا. تركي جاني قال لي السلام عليكم. الرجاء التوجه إلى القاعة الرئيسة. سنبدأ الآن. We'd like to kindly request you to proceed to the main auditorium, so we will start momentarily. Dr. Sarah Basart, is she around?
Hello, hello everyone. Hi. It's time to come back from the coffee break. We are a little bit late, then I will appreciate if you can come back to your seats fast. Oops. I'm doing
I'll present you now. So you invite your guests. Assalamu alaikum wa rahmatullahi wa barakatuh. We are coming to the last session of this conference, which is titled The Weather, Climate and Policy. It will be chaired by Dr. Sarah Bassart, and she will invite the panelists.
Panelists are very fast. Thank you for being responsive. And also I want to invite the rest of my keynote speakers with me to the table. Yeah, Feras, you too. You have a seat also. Then please come. I will mention all of you, which is Baron Orr, which is Paul Cusera. Okay, I will do my best. Yeah. Ahmad Ahmadi and Amira Al-Hassan. Please join us to the main table. Oh, yeah? It's online? Okay. I hope that Amira will be listen us and stream us. But, yeah, it's me. Thanks a lot for your attention. And as you see, I'm in the table well supported. And I am the keynote speaker. I can introduce myself, but someone told me that I have to wait. Sorry.
Hey Sarah, how are you? This is Ahmed.
Nice to meet you.
Hi Bara. Very nice to see you. You too. Doing okay? I'm Ahmed from NCDC. Thank you.
Okay, then I will introduce myself. You saw me yesterday. My name is Sarah Bassart. I'm scientific officer at the World Meteorological Organization, and I'm working in the Science and Innovation Department, that is the research branch of WMO. Oops, ooh, this is fast. Today and yesterday and the day before, we were raising the connection of the sun and the storms and its impacts. And as you know, it's not just weather and climate, it's infrastructures, it's ecosystems, it's economy, life, and health. When we think in sun and dust storms, we can think in this type of pictures, photos from Saudi Arabia, from Kuwait, from Baghdad, for Syria, Also here you can see the modest image that it was a very huge sun and dust storms, but here you have to also realize about the impacts that is having in society. Disruption in traffic, disruption in airports also impacts on health, and some of these impacts was pointed during these days. But it's not just in sources. Here are some landscapes from Europe, and as you can see also, Saharan dust in that case can hit very strongly high latitudes like Paris, Switzerland. You see is the Alps covered by this reddish color, or some cities more in the Mediterranean as Crete, Almeria, or even local sun and dust storms that happens in Turkey. It's because this context that is a global phenomena, for that reason we are saying that is a global phenomena, that the UN, the United Nations General Assembly, proclaimed the 12th July as International Day for Combating Sun and Dust Storms. This day was chosen because we want to raise awareness and to spread the importance for health and sustainability of this hazard that is the sun and dust storms. In this case, a key player in this promotion of the awareness and the mitigation strategies to combating sun and dust storms is the UN Coalition for Combating Sun and Dust Storms. And what is the UN Coalition for Combating the Sun and Dust Storms? The coalition was launched in 2019, and it's basically a group of agencies and international bodies that are trying to work together to exchange knowledge, data, and good practices, also to establish a dialogue and collaboration among the affected countries of sun and dust storms, but also involving the agencies at the international level. And important, we need to mobilize resources just to support all these activities and actions that are proposed by the countries to mitigate the impacts of sun and dust storms. Then the priorities of the coalition are the identification and analysis of sun and dust storms and source areas, help the countries to develop policy plans to mitigate and be adapted to this hazard, identify and implement good practices for source and mitigation and impact mitigation, facilitate the knowledge sharing and capacity enhancement, basically build capacity in the regions affected, and identify vulnerable places and vulnerable populations to try to tackle and tailor the products that they need for mitigate the risk. And the coalition is important. Why? Because SDS, the sun and dust storms, impacts are covered 11 over the 17 Sustainable Development Goals of the United Nations, and also because it's a huge effort from different agencies. As you see here, is listed all the agencies, in total 19, that are working together to really support this development of strategies at regional and global scales. And here I want to point the FAO, the Food and Agriculture Organization, which is currently chairing this coalition, and also the WMO, which is my institution, because the WMO is dealing with the forecasting and early warning activities that is regularly mentioned in the discussions of these days. Also, as I said before, WMO is actively collaborating with UN agencies, some of them present today here as FAO, UNCCD, SKIWA, SCAP, or WHO, and we are working to provide the information and the guidance on how to assess and address the risk posed by sun and dust storms, and to help them to develop the action plans to combat them. In the bottom of the image, you can see some of the reports that are available in the publicly available for you that are trying to tackle the problem, but also to propose some solutions, like the Global Assessment on Sun and Dust Storms, the compendium led by UNCCD, the impacts of sun and dust storms on oceans, led by UNEP, or the Sun and Dust Storms Risk Assessment in the Asian and Pacific, led by SCAP-DIM. And one of the topics of the sessions was health, and why it's important for you is the health component. And I want to emphasize that the last WHO guidelines is also having a section on good practices for management of certain types of particulate matter. In the list is sun and dust storms, meaning mineral dust, and the report is also pointing that there is a currently insufficient quantitative evidence to set up the impacts of dust in health, for example. And I listened in one of the talks that this is stressed, and you can see that WHO also is stressing this lack of evidence. Also, at WHO, together with WMO, we are preparing a report on San Andreas Storm's impacts on health that is planned to be published this year. If we think in agriculture, here it is the set of reports promoted by FAO. You can see that different countries that are affected by San Andreas storms are also engaged in these reports, and you can see how it's covering the topic of agriculture in different aspects, not just in technical aspects. It's also a guide to mitigate, adapt, and policy and risk of management measures in agriculture, for example, or reports over specific regions. And also UNCCD here is playing also a contribution with the identification of the sources. And here is the source map that is also available in the UNCCD website. The map is developed by Anna Vukovic, that you know her, is in the third row. Then if you have questions, you can go and ask her. The exceptional thing of this source mapping is the resolution, the spatial resolution that is 1 kilometer. And why WMO is playing this important role? WMO is the United Nations agency specialized on weather, climate, and water. It's supported by more than 193 members, meaning countries, and coordinates more than 300,000 experts around the world from meteorological and hydrological services, academia, and private sector. Also, WMO is co-founder and host agency of the IPCC. How is working WMO? WMO is having different departments, and in that case, I want to mention that because we are doing a lot of effort in research, but also to promote operations through the data exchange, which is the Department of Infrastructure, and development of best practices and support the development of early warning systems, for example. In the research branch, which is science and innovation, we are covering 3 main areas, which is climate, weather, and atmospheric composition. And inside this atmospheric composition program, that is GO, it is include topics like San Andreas storms, wildfires, or air pollution. And it's because this context of research that WMO launched in 2007 the International Research Program on San Andreas Storms, which is the SDS-WAS, that the large acronym is San Andreas Storms Warning, Advisory, and Assessment System. And I want to stress the word advisory and assessment because it's considered a research program. And what is the main objective of these programs? We want to coordinate in all the international community connected with research for weather and climate. Also, we are working a lot on the identification and assessment of the San Andreas storms impacts. All the people involved in the program is promoting the use of current available SDS products that are available for the final users. Also build capacity and facilitate access to the available services. And this conference is a good example of this kind of exercise that we are trying to support and promote. And also we are working a lot in dissemination and awareness. In the science and implementation plan of this research program, it is stressed that our main goal in the next years is coordinate global partnership to advance the scientific and operational aspects of sun and dust. And this is why we are supporting this kind of conferences that are very valuable for the development of the strategic plans that will come after 2025, for example. But also we are promoting science. One example is these WMO bulletins that are published annually, and you can find in the library of WMO. And there is a special bulletin on airborne dust that is now being prepared, the 8th edition of this bulletin, but you can see the previous ones in the library of WMO. And how is organized the program? The program is organized through the concepts of regional nodes and centers, means that each node is hosting a center that is coordinating all the activities of the node. All the countries are involved, but it's true that there is one country that is hosting the center. And today, I'm glad to say that you have in the room the 4 chairs of these 4 regional nodes that you can see here. The American node in Barbados, here is Andrea. The Barcelona, the North Africa, Middle East, and Europe node that is hosted by Barcelona, and the chair is Anna Vukovic. Also, we have the Asian node that is having the center in Beijing, and the chair is Takashi Maki, that is also here with us. And finally, the most recent node was the GCC, the Gulf Cooperation Country node, that is having the center in Jeddah, and Juman, that is also in the room, and one of the old hosts is the chair of the region. Also, I want to stress the effort that WMO and the research program is doing to promote these research activities in operations. And now, at present, you can have the products of 2 operational centers, Barcelona and Beijing, in the WMO forecasting system. And what we are doing in the research centers, we are trying to provide and promote best practices and best guidelines to use by the international community on the use of the available information. And here, one of the most important activities is the model intercomparison. This is the screenshot of the Barcelona DAS Regional Center. At present, the center is having 15 regional and global models, and this allows us to do more research and understanding how the products can be useful for being used in a potential early warning system or any kind of potential tailored service. Also, it is the benefit that we can work in a more probabilistic concept than giving to the final user an idea about the accuracy of this forecast. And why we support that there will be a new node inside this North Africa, Middle East, and Europe center, why we promote that West Asia has to have their own center, is because this report done in 2013 was stressing different specific features of the region. One is that there is a gap on monitoring infrastructure, then we have to promote, and you have to promote from your countries, the investment in monitoring infrastructure, but also it was justified because it is needed high-resolution forecast systems to really predict the strong sun and dust storms that you have in your region. Why high-resolution simulations? Because the region, as you can see here in the images, are having a complex topography. Then the altitude of the mountains that you have in Oman or in Saudi Arabia can change in more than 500 meters up to 1 kilometer. The altitude of these mountains, if you are running your model at 30 kilometers or at 3 kilometers. This is an example, but everything is connected also with a description of the local sources. If you have higher resolution, you can describe better the sources, and local sun and dust storms more connected with convection and sea breeze. And this is the website of the Jeddah DAS Regional Center. You can see that in the dashboard that is in the website, there are different models, and there is the WorldCam model that is running at 5 kilometers. And now the center is trying to really assess the performance of these high-resolution simulations in the region, and I'm sure that it will be better and better with the pass of the month. And I will invite you to visit also the 2 websites to really follow the forecasting products. And what is important forecasting? Because the early warnings. At the United Nations, we are promoting this initiative called Early Warning for All. And it was because the Secretary General, Antonio Guterres, one day realized that not all the countries of the world are supported by early warnings. In fact, 50% of the countries of the world are not having early warning systems. Then at United Nations levels, it was promoted this early warning for all. And WMO is leading the work package, the working group on detection, observation, monitoring, analysis, and forecasting. And here, I want to also stress that in the list of hazards is considered sun and dust storms. But when we think in warnings and early warnings, we have also to understand why or for whom is oriented this warning. And here it's important to identify the impacts and the ideas for the risk mitigation for a particular sector. And I want to stress that because it's not the same the aeronautical sector that is more worried about visibilities than the solar sector that is more worried about depositions. Then when we want to design this early warning for all and these multi-hazard systems, we have to very well identify what is demanded by each of these sectors. For example, air quality, how is the design of these early warning systems to prevent impacts on health, how much people is exposed, how much dust you need to disturb operations in an airport, for example, or in solar production is what is more important, the deposition, the soiling part, or maybe the impact of the aerosols in the solar radiance. Then, in this sense, I want to raise also that WMO is working in reports that try to describe the methodologies of SDS WOS forecasting and assessment to provide these services. And in that case, this report is led by Slobodan Ničković, Anna Vukovic, and Daniel Tong, and it's also planned for this year. And this is another thing that you can keep in mind. When we identify the impacts, we assess these impacts in the different sectors, and then we have to create the warning. The warning is considering when the San Andreas storm became a risk. And in this case, you can see a couple of examples on how you can define risk based on the impact. We have to establish in which threshold the amount of dust is really a risk for a specific purpose. And in that case, if you visit the website of the Barcelona Dust Regional Center, you will find these products developed under CREUS project that is basically a way that they can follow if there will be an intense event in the region. But also, I want to stress the work led by Escapadin on this risk assessment for Asia and Pacific that includes the assessment in 5 different sectors. And my final remarks. You know that San Andreas storms play a significant role in different aspects of weather, climate, and atmospheric chemistry, but also more important, represents a serious hazard for life, health, property, environment, and economy. Understand, managing, and mitigating the San Andreas storms risk and effects requires fundamental and cross-disciplinary knowledge. And here it is going the international cooperation, which is important. The UN agencies are working together for designing and coordinating an international mitigation and adaptation strategy for combating San Andreas storms. And here, the UN Coalition for Combating San Andreas Storms is calling for the global response to these mitigation impacts. Also, it's important here to stress that we need mobilize resources at national, regional, and global scales. And here, as last sentence of my talk, I want to emphasize that WMO is key to provide information and guidance on how to assess and address the risk posed by San Andreas storms at local, regional, and global scales. And with that, I want to thank your attention. I want to thank especially the colleagues from other agencies that are sitting here today, especially FERAS, which is one of the co-authors of these slides as a chair of the UN Coalition. And also, if you want to follow all the activities of the SDS WOS and WMOs, please scan the QR and subscribe to our newsletter that is monthly. And thanks for your attention. Now, going to the next speaker, I want to invite Baron Joseph to the podium. Thank you. And he will introduce the UNCCC's proactive and collective response to San Andreas storms from policy to practice. If you can be fast, it will be appreciated.
I will do my best. So with that, the good news is that quite a few of the slides that Sara just presented are replicated here, so we can go through those pretty quickly. So we have already talked about this history, but I think it's important to recognize just how embraced all of this is in both the General Assembly resolutions and through a response really each time inside the UNCCD, which gets down to specific tasks like these, the policy framework that you see here, the assessment, the global assessment, and also the compendium. I think that this is also important to recognize that it's very well structured so that all the stakeholders can participate where they fit in these three pillars. The coalition has been defined in great detail, but I want to emphasize it because without it, this collaboration would be very siloed, and instead it's highly collaborative. The compendium is now moving us into the space of looking at risk and impacts, which is essential. And as I mentioned in the first day, that we are now looking at trying to help policymakers incorporate this into their national strategies and action plans. In addition, all the tools that are being developed, there's sort of a clearinghouse that's been made available, which is called the SDS Toolbox. It's online on the UNCCD website, and you'll see the pillars mentioned here, and you will also see, like Anna Vukovic's global SDS source map. So it's a powerful way of bringing all of this together, making it accessible, and giving credit where credit's due for whoever produces each element. So we come at this from the ground up. We're with the UNCCD, and our focus is to move towards healthy land. So our emphasis is on the source mitigation or working with parties to pursue that. We think about this holistically in terms of the drivers, but we both look at this from the side of it that's direct in this, particularly those that are impacting the land, and the indirect drivers that actually influence this in a contextual way. So when we think about those indirect drivers, it's important to recognize that we're often having this discussion about natural versus not natural dust, but the same thing happens on the landscape, and natural ecosystems can become degraded and in the process contribute to this problem. It's natural in the sense of the actual movement of the dust and sand, but we need to address that so it's not an additional contribution to the problem. So the key to this is, of course, identifying and monitoring those source areas, but also focusing on what do we do in those spaces. And sorry, in that regard, it's probably the richest base of knowledge for everything related to land is our knowledge about practices for sustainable land management. And I'll mention WOCOT here, the network, and where the database is held. So linking this to what we know about sand and dust storms is really, really important. It's important to also recognize that we're thinking about this, again, holistically, from preventive through to protective measures in terms of the landscape, and bottom line, reducing soil exposure in all ways possible. I won't go into any details here, but I think it's the compendium goes through this in great detail, so you can break this down relative to the reality that you're facing on the ground in any given circumstance. So when croplands, rangelands, natural ecosystems, and of course this whole issue of windblown sand. I want to also emphasize, because the ease to talk about restoration from the perspective of planting trees is a two-edged sword, right? We don't want to plant trees where they don't belong. So we have to keep in mind that all of our interventions need to have ecological foundation and to follow that. That's extremely important. So another aspect that's very important is to consider this in an integrated way and not siloed once again when we're looking at the solutions on the ground. So we're looking at this from the point of view of what we do on spot, sustainable land management. We're looking at it as an integrated landscape and how the pieces fit together and influence this through the vertical side of this, right? The supply chain influences that may be on this. And then we bring the same thing into play when we talk about water and integrated water management. Integrated landscape management has an advantage when we're looking at addressing source in that the economic viability of what we're doing and the sustainability of it is going to be entirely dependent on how it influences the livelihoods of those using the land. And if we keep ourselves in small project areas, we'll never succeed at doing that because often degraded lands have no economic potential, but they still have to be addressed, which means that those areas that do have economic potential nearby should be integrated in our solutions so that we have success down the road. And there are many examples now globally of doing that. This is just to give you a snapshot, right? That landscape, if I didn't have the flags with the words, would look simple, but it's not simple, and the solutions vary location by location, and we need to consider them all relative to each other. That's the integrated approach. The IPCC, looking at this holistically, gives us a whole continuum of response options from what we're doing on the ground all the way to the value chains and the incentives that are tied to those value chains. But one size does not fit all. Every location, every landscape, every watershed, we have to consider what's right for there. I just want to re-emphasize this key of early warnings for all. We have to have an approach that isn't thinking about this solely in our scientific domain or our policy domain, but rather from the perspective of who's impacted by sand and dust storms, which will then lead to a much more effective risk monitoring and approach, right, for early warning. I also want to emphasize that this is a transboundary problem, and in conventions, sovereignty is everything, but we can't let sovereignty dominate when we have an issue like this. We got to move away from the finger pointing and move towards collaboration. It's key. One thing that's a big advantage here is that in the UNCCD and therefore globally, we pursue a balanced approach, meaning a no net loss approach to how we look at land degradation. And that frame is very powerful for sand and dust storms because it allows you to optimize what you do where and to consider everything holistically, which is fundamental to many of the presentations I've seen over this week. It also means, if you look at the third bullet point, it means that if we can keep land in balance, we can keep food, water, energy, carbon, biodiversity in balance. This means that our solutions can be multiple benefits because of our frame, how we look at this. It's a resilience framework. It fits very well in the context of climate change and biodiversity. It's about doing the right things in the right places at the right scale, a simple way of describing land degradation neutrality. And SDS, as I pointed out, allows us, other way around, LDN allows us to look at SDS into that context inside a national approach all the way to the watershed. It also is key that funding is connected to that very integrated philosophy, but it's important to recognize that we're not there, right? We don't have the funding mechanisms that are necessary to drive this. We're doing okay, but not nearly as well as we will need to be doing. But think about it. If we think about how integrated this is with all of those other objectives, we ought to be able to raise those kinds of finances to address sand and dust storms. And with that, I pass it back to Sara. Thank you. Thank you.
Thanks a lot for the presentation. And we will move to the next speaker very fast, which is Paul Kucera, and he will present the development of the regional dust forecasting system to support the dust early warning systems in the Middle East. If you can reduce your slides as much as you can, it will be appreciated. Thank you.
Okay, I will try. Okay. Hard to see it. Yeah, anyway, I just want to thank the organizers for allowing me to be here today and listen and also present some of our work. So what I want to present in the little time that I have here is just kind of an overview of what we've been working on with the National Center for Meteorology over about 10 years to build a forecast system to help with early warning. So just as we've been hearing throughout the conference, just the dust impacts. So the Sahara has the largest amount of dust sources, but this region has a strong secondary impact to dust around the world. Dust storms are one of the most severe environmental hazards in this region. So some of the direct impacts: visibility and air quality degradation, damage to buildings, vehicles, trees, and so on. Disruption to roads, air traffic, and outside activity. Some of the indirect impacts, as we've been hearing this week: effects on clouds and precipitation, and effects on the local climate. So from our studies in building the forecast system, the primary dust sources are local in this region, around this area, and then secondary from the Sahara Desert. But regional transport outside the Arabian Peninsula also plays an important role as a dust source. And then up to about 40 different chemical elements have been observed and reported through research in this region. So dust storms are a year-round phenomenon around this area. The highest season tends to occur around about now, based on our studies, and a secondary impact in the winter. Most storms occur during the heat of the day through the instability, stronger winds, and as you can imagine, some of the storms are local and minor, can last for just a few hours to several days. All right, so just want to present quickly the motivation of why we started working on building this forecast system here. And this goes back to March of 2009, where there was a very large dust storm that took place over this region. The storm caused widespread heavy atmospheric dust load, very low visibility, the airports were closed, damage to vehicles, trees and other things were damaged. And one thing that was really important is actually here in Riyadh, based on the news reports, there was very little warning for this event. So it was a very high impact to society. So we wanted to see if we could provide a prediction system that could help with this. So here's just an example of that event. You can see large areas of dust on the west side of Saudi Arabia and also over the Arabian Peninsula, based on satellite observations. So our original configuration is shown here. We've been using WRF-Chem as our foundation to build the dust forecast model. In this initial study, we started with 2 domains, a 7-kilometer inner domain and an outer domain of 21 kilometers. And we were able to do verification studies with observation site very close to here in Riyadh called the Solar Village. So for a study, WRF-Chem was initialized on the 9th of March. For the outer boundary conditions, we used ANSEP final analysis products. We looked at different initialization times for sensitivity studies, and then we included the Mozart 4 data set to see if we could improve upon the dust forecast with this additional data set. So here's kind of the initial results, just showing the different lead times in the In the three different plots, the observations from the solar village is in that light gray, and then the forecast from the inner and outer domain are in the darker colors and the dashed. And you can see as you move from a long lead time of 5 days to a shorter time, you get slightly improvement, but it's still, there's an offset in when the event occurred. However, when we added the Mozart data sets, so the top panel, again, this is AOD with time. You can see without Mozart data, we're getting close to capturing the event, but not quite. But when you add that extra data set into the simulations, you start getting a much better agreement between with the model and the observations. So just based on this initial kind of proof of concept, this initial system was able to capture the arrival, evolution, and the distributions of the dust storm. The initial studies, the onset was delayed by about 3 hours based on observations. The Mozart data really improved the background chemical conditions. What I didn't show, but the simulated observables were very close to what was observed, both in magnitude and evolution. And then the higher resolution, shorter initialization times improved the model performance, as you might expect for AOD. So overall, we were excited about the results, and we use this as a framework to continue on. So just a little overview of the kind of evolution to the current system that's here today. So we initially decided we wanted to build a higher resolution forecast system. So high resolution for our framework was 6 kilometers to support NCM's operational capabilities. We did this initial analysis based on that case study and other cases from 2012 to 2015. We have 2 models running, just a WRF ARW for standard operational forecast products, and then WRF Chem for the dust forecast products. And then a second generation of modeling systems were developed starting in 2018 and are now operational here. And what I wanted to highlight is the partnerships that went into this. So us at NCAR working on the modeling development and testing, NCM, the experts to provide feedback on the forecast products for the region. And then we've been running and doing the research and testing at the King Abdullah University of Science and Technology, which is just north of Jeddah, using their HPC computer. There's resources to test the system. So here's our model domain. Outer domain is shown there, and then inner domain. We also did a 2 kilometer third domain, but because of resource limitations, we don't run that in real time. But it's centered kind of over the Arabian Peninsula. Based on looking at many case studies, 20, 30 case studies of dust events, these are the parameterizations that we came up with that best predicted the dust forecasts in this area, or observations. And what we've been doing now too is actually initializing the system with GFS and ECMWF to see kind of like a poor person's ensemble on having at least 2 different forecasts that are available for the region. The dust products that are produced here now in real time, so the aerosol optical depth, surface concentrations, dust load, and wet and dry deposition. Here's just an example of one of the products on the display here. So just moving to case study, what we're seeing, the observations of MODIS are on the left, the forecast are on the right for this one particular dust storm on the 20th and 21st of January 2021. What we're seeing, even with a 4-day forecast, the model is very consistent of identifying and predicting these larger scale dust events. So just kind of a summary of where we're at now. So both the GFS and the ECM-driven forecasts have predicted the majority of the significant large-scale dust storms that have impacted this area for the last 6 years of our research and development. However, the small scale, the localized dust events, results are mixed. Sometimes we can capture them, sometimes we can't. But what we've seen, if you initialize with GFS and ECMWF, they provide very consistent simulations. If GFS sees or predicts a dust event, the ECM also would predict an occurrence of a dust storm. However, the concentrations initialized with ECMWF, for whatever reason, tends to be smaller in size than using GFS. So still, this is an ongoing research collaboration to always try to improve upon that prediction capability. So what we've done also testing development is developed a framework for an ensemble-based dust forecast system. We've gone through all the testing, looked at case studies. It's just that there's not the computational resources at the moment, but the whole idea is to provide some probabilistic forecast information that can be used to look at the risk of these different events moving forward.
That's 2 minutes.
Okay, I'm almost done. I'm trying really fast. One of the other things that we've done is develop a framework to run the forecast models in a cloud computing environment. So you can run it on demand with the different resources they may have for either for case studies or for operations for certain high impact events. The framework's been developed that it can be done quite easily and efficiently. So just to summarize, what I've just been talking about the last few minutes, we've developed this dust forecast system in collaboration with other partners to provide this dust forecast guidance for this region. We've seen over and over it performs well for large dust events, but there's still a lot more research and development being done. And one thing I want to, if you want to take away and want to highlight to really advance our prediction capabilities is really to have coordinated partnerships. We've had great partnerships with NCM, working with university researchers, research centers, and other stakeholders that need this information for making decisions. Is really, really important to move this forward in this region and in any region around the world. So with that, I thank you and thanks.
Thanks a lot for your kind support to reduce the time. We will have some space for questions. And our next speaker is Ahmadi from the National Center for Vegetation Development here in Saudi Arabia, and he will introduce the role of the Saudi Green Initiative in developing vegetation cover and mitigation dust and sand and storms.
Thank you. Assalamu alaikum wa rahmatullah. Alhamdulillah, wassalatu wassalamu ala rasulillah. Hello everybody, this is Ahmed Al-Ghamdi, the head of the Research and Innovation Department at the National Center for Vegetation Cover and Combating Desertification. I'll try my best very quickly to shed light on the Saudi endeavors to mitigate land degradation and sand and dust storms. So first of all, as a global land degradation perspective, I would, for example, give the one example for the SDG indicator 15.3.1, which reveals that an increase of the degradation from 15% around the period of 2015 to 19% in the year 2019, which is really equivalent to 1.2 billion hectares, which is a scary, of course, figures. This is, and in fact, only between the year 2015 to the year 2019, there was a loss of about 280 maybe million. I'm sorry, I cannot see enough in here because of the light, but and also we say in Arabic لا يفتى مالك في المدينة ولا يفتى بار في المنصة, which means in English I cannot give verdicts and figures while Baron Joseph in the stage, But anyway, there is really scary figures about the land degradation, which leads to sand and dust storms. Anyway, so also, unfortunately, the reporting process of the degraded lands isn't complete yet. Only 56% of the total land area is reported, as you see. We all know that the land degradation is affecting our life in many dimensions. One of them is the environmental dimension in terms of biodiversity. For example, now there is some figures that said that the land degradation causes critical habitat and biodiversity loss. It is said that also reported that 1 million species of the almost 800 million species of plant and animal species are at risk of land degradation, to the risk of extinction. Also the water cycle. There is a problem, of course, with the water cycle. As you know, globally now nearly 1.8 billion people living in areas with water scarcity. And this problem is escalating by the years. Also, when we speak about soil health, the degradation in soil and the soil erosion that takes place at the moment is really scary, and it is more than 1,000 times that the earth used to experience in the past. Which in some figures saying that now let's say the removing of the soil layer of the topsoil is there is a huge number by 25 to 40 billion tons of topsoil being ripped away every year. Also the air quality, and here we speak about the dust and sandstorms. The air quality also we are having some problems while the land degradation is escalating this problem. Also, when you speak about the impact on the economy and in general, in the gross, in the GDP, the gross domestic product, and here you will see some figures about the impact of land degradation on GDP globally, and also by, let's say, at the corner of this slide, there is encouraging also news about when we try to rehabilitate, restore, and combat all this degradation, that we can gain high amounts of course, of income once we deal in the correct manner with our environment and prevent and halt degradation. Also, in this the societal impact in terms of food security, there is some figures, and also for health and safety, and for the more forced migration. You will find here some figures really it's not encouraging at the moment. So let us speak about the Saudi context. Of course, in line with the Saudi vision, which been declared at 2016, the kingdom showed a strong commitment to safeguarding the environment. Under the achieving the environmental sustainability theme in this vision, there was a commitment, or let's say objectives, 3 objectives. The first one is to reduce all types of pollution, including air, sound, water, soil. The second one is to safeguard the environment from natural threats or hazards. The number 3 is to protect and rehabilitate natural landscapes. And now we are having many targets, clear targets, and under this agenda or under this theme. For example, now we have the target of reaching net zero by 2060. Also, we have the target of 50% of energy from renewable sources by 2030. Also, there is another target for reaching 30% of land and sea areas to be protected by 2030. Also, our center, the National Center for Vegetation Cover, has its own target by 2025 to rehabilitate about 86,000 hectares of degraded lands. And here, just let's say chronological, historical, for the environment agenda in KSA, which is, as I mentioned, it started since the declaration of the Saudi Vision 2016 and the establishment of the Ministry of Environment, Water and Agriculture. And then in 2018, the national strategies for environment, also for water and for agriculture has been declared. Also, the SDGs KSA voluntary national review has been reported or has been done. In 2019, let's say about the environmental sector, the institutional setup for the environmental sector was completed at that year by announcing the 5 environmental centers, the National Center for Vegetation Cover and Combating Desertification, NCVC, the National Center for Environmental Compliance, NCE, the NCEC, the National Center for Meteorology, our host today, NCM, the National Center for Waste Management, National Center for Wildlife Development, which is being supported by the Environment Fund. In 2020, during the conduction of the G20 and Riyadh Summit, there was a declaration of 2 important initiatives, environmental initiatives. One of them is the Land Degradation Initiative. In 2021, also, there was really a huge declaration by the Crown Prince of the Saudi Green Initiative and the Middle East Green Initiative. In 2023, we were lucky to finish the studies, I would say, for the afforestation program under the Saudi Green Initiative, which being presented to the Crown Prince and been announced last year in 2023. And this year we'll be holding hosting the COP16 for the UNCCD. Again, for the SGI, which is the most notable, I would say, initiative, under this initiative, there are many key activities, which is one of them is to increase vegetation cover and combat desertification, to increase the share of clean energy, to conserve biodiversity and ecosystems, to reduce greenhouse gases emissions, to transition to circular economy. And there is clear targets under each one of these ambitions. For example, reducing the greenhouse gas emission will be to reduce carbon emissions by 2030 by 278 million metric ton, and also to plant about 10 billion trees across the kingdom to greening Saudi Arabia, and to rehabilitate about 40 million hectares. Also for the protection of wildlife, there will be protected areas, whether inland or terrestrial, which is equivalent to 30% of the land and sea of Saudi Arabia.
2 minutes.
Okay, so in Saudi Arabia, the SGI, I would say it is really, we hope and we make, to see this is really a successful initiative, as we already achieved in 2030 planting more than 40 million trees. And there is an endeavor to plant more than 400 million trees by 2030 and to plant the rest of the 10 billion by 2100. And the idea in here is not only planting trees, but also to enhance protection of vegetation cover, to use renewable water resources, to leverage native species, to maintain ecological balance, to employ sustainability modeling, and to engage the stakeholders and the local communities. Here are the domains and regions that we are targeting to with this under this initiative. For example, there we have environmental domain, we have urban domain, we have highway and special areas, and agriculture domain. I mean, all the domains will be working with us under this initiative in Saudi Arabia. And here is some of these initiatives that already working now and having some clear objectives or objectives by 2030. And this is the governance and how in here the stakeholders, whether from government entities or from the private sector or for the mega projects, and the role of the innovation and research in this initiative. Before I end my talk, also I'd like to mention quickly the MGI target to plant 50 billion trees in the region, which is equivalent to 200 million hectares of degraded lands. Also, the G20 Global Land Initiative, which has been declared during the G20 summits, and the main objective of this global initiative is to prevent, halt, and reverse land degradation with an ambition to reduce degraded land by 50% by 2040. And there are now about 20 countries who supported this initiative, and the number is increasing. Last thing, you all welcome to the COP16 Riyadh in December 2024. Thank you.
Thanks a lot for being time. The next speaker, if I'm not wrong, is online. I don't know how to manage that. Someone is taking care, right? Very well, yeah. No? We don't have online talk, or we have some, yes? No? We have? Okay. Then I hope that Dr. Amira Al-Hassan is listeners. She will introduce. Yeah. Welcome.
Thank you so much.
Dr. Amira Al-Hassan will introduce the UN Habitat's role in the UN San Andreas Storm Coalition for UN Coalition for Combating San Andreas Storms and Gulf Climate Action for City Resilience. Dr. Amira, I don't know if you have control of the screen, but yes. We cannot see your screen at the moment. No, we cannot see her. I can see her. Hello. I cannot see your presentation. I don't know if you have to share or change the screens. Yes. Maybe we have to change the screens. They are working, no worries. Everything is going.
Okay, can you hear me?
Yeah, we can hear you. We can hear you. No worries. And we can see you. Also, we can see you.
Okay, Assalamu alaikum, marhaban. Thank you so much. Muchas gracias for your introduction. And I would say thank you so much for the organizers of the المؤتمر الدولي الأول للعواصف الغبارية والرملية في الرياض. Really, this is a great opportunity for me to be in touch with you via the internet, and I will be as short as possible. I was informed I have 15 minutes. Already 1 minute has passed, so let's start with the United Nations Coalition on Combating Sand and Dust
We can
Storm.
see your screen now. We can see your slides, then go ahead. Yeah, we can.
Okay.
Yeah, we can see your screen. Yeah.
Okay, great. So the United Nations Sand and Dust Storms Coalition emerged as a global response to the increasing frequency and intensity of sand and dust storms. These natural phenomena, primarily caused by land degradation and desertification, have severe impacts on the environment, human health, and economies of the Gulf region. The coalition was, and also around the world, globally. So the coalition was established to foster international cooperation and develop effective strategies to mitigate the adverse effects of sand and dust storms. Sand and dust storms pose a significant threat to human health, causing respiratory problems, cardiovascular diseases, and eye infections. Sand dust storm also can devastate agricultural lands, reducing crop yields and food security worldwide. And with the increasing number of sand dust storms as a result of many factors, this devastating effect is growing rapidly in unprecedented way throughout human history. So the infrastructure damage from dust storms disrupts transportation, communication, and energy supplies. The economic cost of sand and dust storms are substantial. So the United Nations coalition was established in 2019 through the United Nations Convention to Combat Desertification, UNCCD. It is established so far out of 19 organizations, as you see on the screen, including UN Habitat, UN Environment, UNEP, ICAO, ESCAPE, and other agencies are also invited to join the coalition, as every agency has their mandatory work and they focus on a certain angle that is related to sand and dust storm. The role we play as a coalition is to promote and coordinate a unified UN response to sand and dust storms, facilitate knowledge sharing and best practices among members, advocate for increased funding and resource mobilization for affected countries, foster collaboration between countries and sectors to address sand and dust storms, raise public awareness about the issue and its solution, as every region of the world is experiencing sand and dust storm as a result of different factors. So looking at the main reasons behind this growing phenomena will really result in a joint effort that focus on each region's reasons and each region's interventions that are needed. So the achievements here are a development of a comprehensive action plan to guide future efforts, establishment of working groups focused on specific areas like early warning systems and sustainable land management, increased international cooperation and resource mobilization for affected countries, and preliminary data suggest a decrease in the frequency and intensity of sand dust storms in some regions of the world. What regional coordination can achieve? It can reduce mobilization, it can regulate a regular exchange at the level of decision making, regular updates on the status quo, sharing of data and information on the proliferation of sand dust storm and hotspots, sharing of know-how on successfully combating sand dust storms and on building resilience, including best practices, awareness raising about the impact of sand dust storm economically, health-wise, qualitatively and quantitatively, joint policy formulation, joint programming or project development. So what role the UN Habitat has played as a member of Sand and Dust Storm Coalition working towards leveraging city resilience? In fact, if we look at the coalition, it is a concrete step towards catalyzing science, innovation, investments, and actions to enhance cities' resilience against sand and dust storms. From the UN Habitat perspective or point of work, the UN Habitat has started and established a project in southeast of Iraq in 2021 through funding from the Kuwait Fund as a projection to leverage Gulf cities' sand dust storms resilience by rehabilitating the hot spots using innovative solutions. In this respect, I would emphasize that interventions that will take place in any country has two scopes of work. One that requires funding because the interventions are heavy in terms of demanding the knowledge and the know-how of the experts and the expertise from every entity that is related, and also involving the locals at voluntary work of locals will include raising their awareness about what is being done and how they can collaborate with the entities that are involved in rehabilitating the hot spots. So without any delays, I will go to the conclusion of my presentation, which is this approach is a pioneering and innovative approach towards reducing the sand and dust storm transboundary impact on the region. The UN Sand and Dust Storm Coalition is another step using the One UN initiative, which entails having all agencies with their different expertise in one hand in hand, working together to resolve this challenging problem that is increasing worldwide. International and cross-boundary resource mobilization are required and very important and imperative to have resource mobilization for impact optimization. And in this regard, I would emphasize again that our work in Iraq as a first stage is very important to tackle a problem that is affecting the whole 6 Gulf countries, but there are other hotspots that need more resource mobilization, mitigating the effect on Kuwait, Saudi Arabia, Bahrain, Qatar, and Oman, and United Arab Emirates. So regional cooperation is a successful recipe for reducing transboundary sand and dust storm events and desertification and mitigating the climate change impact. Rehabilitation of the topsoil by planting native plants will mitigate the effect of the climate change by increasing humidity and oxygen levels and improving the fauna and the flora of the region, as well as incarcerating and capturing the carbon dioxide in the barks and the plants that are planted in that region of the world. Finally, I thank you so much for allowing me to reach out to you in this conference, and I look forward to any questions that can be raised following my presentation. Thank you so much.
Thanks a lot, Amira, for your nice talk. And because this panel was fast in the interventions, in the talks, we have time for some questions. I don't know, in the audience, if you have any questions? No? Oh, I can see a question. You can open your micro.
Assalamu alaikum. My question is to Engineer Ahmed Al-Ghamidi. Actually, I am glad to see the great efforts that you have done to increase the green land in the Kingdom of Saudi Arabia. May Allah subhanahu wa ta'ala bless these efforts. But my question is that, as you know, plantation requires lots of water. It's water intensive. So where do you guys bring that water actually?
Thank you. This is really the typical question which we receive every day. First of all, we have enough treatment, I would say, treatment plants here in Saudi Arabia. Now, at the moment, we have more than 150 sewage treatment plants, which produces a lot of tertiary treated water, which is really good for the afforestation projects all over the kingdom. This is one, I would say, effort that we are trying to exploit in the near future, and we are using it at the moment. Also, we are planning to, of course, to plant more halophytes. One of them is the mangrove along the sea coast. We have long sea coast along the Red Sea coast or the Arabian Gulf coast, and as you know, we will be planting this by the seawater. We are not, using any fresh water in here. So these are some of the efforts that we are exploiting to make the Saudi initiative successful, inshallah. Thank you.
Thanks a lot for your explanation. I don't know if someone else in the room wants to raise a question to the panel. I can see a question in the, please open the micro and. Hear you.
Thank you very much.
No.
Yes. My question for Ahmed Al-Ghamdi also, if you don't mind, regarding the plantation or the cultivation of the trees, future planning for plantation, is need to be tackled the hotspots for the sand and dust storms in the region. For example, some researchers in Saudi Arabia mentioned, for example, the area between Kuwait and Saudi Arabia, which is called Al-Qaysuma and Wad al-Batin, is a huge source for Riyadh area. These should be in future planning for plantation in order to stabilize it and fixation. Other questions for Dr. Amira Hassan. Dr. Amira, you have a success story in Iraq with cooperation with Qusr and Kuwait funds. If you can give us a hint about this, we would be appreciated regarding this. Thank you.
Yes, thank you. Again, adding to the previous answer, I would say yes, we are using the native species, native trees, which is well adapted to these harsh conditions. So we are not consuming these amounts of water, and we need such projects in these areas, especially in the I would say in the north east of the country, and there are many projects undergoing at the moment and in the near future, hoping to prevent and halt some of the degradation over there and prevent sandstorms in the future, inshallah.
Thanks a lot again for your nice explanation. And there is another question. Yeah?
There is a question for Amira.
A question. Sorry. Yeah. Sorry, Amira.
Yes. No, that's fine. Thank you so much. And okay, I will elaborate shortly on the project we are conducting in southeast Iraq. It is really fortunate because this is the first of its kind project that uses innovative solutions in the Arabian region. The sand and dust storm events has increased in the last 40 years. It used to be 20 events per year. It became more than 120 days annual events. But the sources of sand dust storm coming and covering the Gulf countries are multi actually sources. One of them that lays inside Iraq, and that's how we in this phase has secured the funds that is over $13 million to rehabilitate the source that will, by the end of this phase, we are hoping to decrease the amount of sand dust storms by 35%. In this regard, we are using many efforts, for example, using satellite imaging to scan the flora and fauna and type of vegetations in the area, and as it was well mentioned, that it's not a matter of planting, but it's a matter of sustaining these interventions. Therefore, using clever ways of irrigation by planting native plants that will be adapting to the desert climate. This will be very much helpful in terms of lowering the irrigation to the lowest and minimum possible in light of the high heat of the Gulf that reaches 55 degrees in desert areas. We are also fortunate to have Kesar on board with us, because we need also science in terms of monitoring the areas and monitoring how much successful our interventions. Do we use fencing, artificial fencing, or natural fencing through planting trees? What kind of trees that are more part of that area of the world, because we don't want to bring in non-native species, as well as involving the locals in terms of raising their awareness, involving them in the interventions, and training them on vocational training that entails maybe planting crops in the coming stage, depending. So all in all, thank you so much for mentioning it as a successful story, which is really we are proud of as a UN Habitat, but also it enabled us to work as a United Nations coalition to shed light on the possibility of replicating this project in terms of hotspots that are inside Saudi Arabia and affecting other Gulf countries and affecting Saudi Arabia as well, and securing funds for the coming stages of this intervention. I hope this clarification is short and clear. If not, then please let me know. Thank you so much.
Thanks, Amira. I hope that, yes. We have one question over there. Yeah, open your micro and try to be close to the micro, or otherwise we cannot listen you. Thank you.
Thank you for the presentation and talks. Mona Dawalbeit from FAO, KSA. My question regarding to the UN coalition. In fact, the UN coalition to combat sand and dust storm is mentioned from each speaker. However, I expected to listen or to know specific programs or projects, especially the regional one. I know that it was established in 2019, but really I expected to, to know what specific programs and in which regions that could be proposed or implemented. Thank you.
Okay, thank you so much.
If you don't mind, I will invite also Feras, that is with us, the chair of the coalition, to contribute to this discussion.
Yes, for sure, because FAO is right now heading the coalition, and really grateful for Dr. Firas for taking over. Thanks.
Thank you very much. First of all, I would like to thank all the speakers from UNCCD, WMO, and UN Habitat who brought in the coalition as an action or response from UN to combat sand and dust storms. Just to emphasize that the UN coalition has two advantages, or comparative advantages, let's say. One is the geographic coverage, which is global, meaning that one of the important things of the coalition is to link the regions and the countries together. But that's not the only one. Also, the coalition is promoting actions at national level. So we have to keep in mind that there are actions, and this is to answer your question, Dr. Muna, that actions that the coalition is doing is at national level, at regional level, and at a global level. The other important thing is the diversity of the themes and sectors that the coalition is covering. Given that the sand and dust storm is a transboundary issue and also is a multi-sectoral, multidisciplinary issue, we have in the coalition all the related UN organizations from land, from agriculture, from meteorology, from health, transportation, climate change, you name it. And that's why you can find the coalition everywhere. And what we are trying to do is to bring all these sectors and regions into integrated approach. And this is very important, to integrate all the sectors together, to integrate the trans-boundary together, the countries together, but not to forget about national efforts. For the coalition, there is a working plan to raise the awareness, to enhance the projects that the coalition members are doing, and we try to synergize this. We prepare each year a Secretary General, UN Secretary General report that put together all these activities. So if you are interested, there is a UN Secretary General report that you can go back to 2019 and you start reading that report where all the activities of the coalition members are there. And something also not to forget, that with the support of the coalition and the request from countries, the UN General Assembly announced the 12th of July as International Day of Combating Sand and Dust Storms. And this year will be the first celebration for this occasion. So I invite you to organize your events and to make sure that there is a visibility, there is publicity about this event, to raise the awareness about sand and dust storms in all regions and countries for more efforts and integration. I think that's for now what I want to say, but if there is any more interest, we can also talk and we can explain to you the role of the coalition. Something we are really now up to after this conference is two things. One is to enhance international cooperation, because this is a transboundary issue. We cannot solve it by one country. Second is resource mobilization. We have to think about climate financing, any kind of financing that will help countries to foster actions for combating sand and dust storms. Thank you.
Thanks, Firas. We are glad that you can manage to come to the conference. And then now I just want to thank all of you for being in time and for contributing to these nice discussions of today. And we can close the session because we are late, right? Yeah. Thanks a lot for your... yeah, after, no worries. You will have the picture, guys. Yeah, with that, we close the session and hope that you enjoyed the sessions of today, the day before and yesterday. And I will pass the floor
Thank you, Dr. Sarah, for committing to the designated time. Now I'd like to invite Dr. Jamal Gahtani to honor the chairman and the speakers as well. Starting with Dr. Sarah Basars. Dr. Baroon Joseph. Dr. Paul Kuchira. Dr. Ahmed Al-Ghamdi. And last but not least, Dr. Amira Al-Hassan. Okay, sorry. Okay. Ladies and gentlemen, we're coming to the conclusion of this. Dr. Rami Al-Farra. With this, we've come to the conclusion of the conference. Now we're going to invite the organizing committee chairman and the representatives of the scientific committee to come to the stage as follow. Dr. Jamal Al-Gahtani, please to the stage. Dr. Rami Al-Farra, Dr. Majdi Al-Tuhi, Dr. Ala Mhausha, Dr. Turki Habiballah, Dr. Najoud Al-Ismaili, Dr. Marwan Al-Saggal, please to the stage.
I have a last petition before to close, definitely. If we can take a picture of the SDS WOS regional chairs together, which is a very exceptional moment, it will be welcome. Thank you. Of course.
Just to draw your attention that the final communique will be recited in Arabic. So please use the translation devices to listen to the final communique in Arabic, final declaration. It will be read in Arabic, so please you can utilize the interpretation devices in front of you to listen to the final communique. Now it gives me a great pleasure to invite Mr. Hussein Al-Gahtani, the spokesman of the NCM, to recite the final declaration. And please As I said, he'll be speaking in Arabic, so you are encouraged to use the interpretation devices in front of you.
السلام عليكم جميعا. أستأذنك سعادة الرئيس بأن أتلو البيان الختامي للمؤتمر باللغة العربية حتى تتمكن وسائل الإعلام الرسمية من نقل البيان، وسيتم عرضه على الشاشات وأيضا الترجمة عبر أجهزة الترجمة الموجودة في القاعة. بسم الله الرحمن الرحيم. عقدت المملكة العربية السعودية ممثلة في المركز الإقليمي للتحذير من العواصف الغبارية والرملية المؤتمر الدولي الأول للعواصف الغبارية والرملية خلال الفترة من 4 إلى 6 من مارس 2024 بالعاصمة السعودية الرياض، وذلك في إطار التزامات المركز وتوجهاته الاستراتيجية المعنية برفع كفاءة التعامل مع العواصف الغبارية والرملية بالتعاون مع المنظمة العالمية للأرصاد، وإدراكاً لحجم الآثار الناجمة عن العواصف الغبارية التي تشكل هاجساً للدول وشعوبها بسبب ما تخلفه من آثار سلبية على المنطقة في ظل العوامل المناخية التي تعيشها من تصحر وجفاف وندرة للموارد الطبيعية إضافة للظواهر الجوية المتطرفة. وقد حرص المؤتمر على دعوة الدول والنخب من القيادات والخبراء والمختصين والمعنيين ذوي الاهتمام بعنوان المؤتمر، وتمثل ذلك من خلال مشاركة الدول والخبراء والمختصين في تقديم تجاربهم وآرائهم ومقترحاتهم التي أثرت جلسات المؤتمر. وقد خرج المؤتمر في ختام أعماله بالتوصيات التالية: 1. ثمن المؤتمر عالياً الدعوة الكريمة من المملكة العربية السعودية لعقد المؤتمر واستضافته وحسن تنظيمه، كما أبدى المشاركون إعجابهم بالقدرات والممكنات التي يمتلكها المركز الإقليمي للتحذير من العواصف الغبارية والرملية والإنجازات التي حققها منذ إنشائه. 2. شدد المؤتمر على ضرورة الاستفادة من القدرات التقنية والعملية والبحثية للمركز الإقليمي للتحذير من العواصف الغبارية والرملية بما يحقق أهداف الدول من خلال توسيع نطاق مهامه ليشمل دول إقليم غرب آسيا والشرق الأوسط، نظراً لما تعانيه أغلب الدول من الآثار الجسيمة للعواصف الغبارية والرملية بسبب تبعات شح مواردها الطبيعية وحاجتها إلى الدعم الفني من المركز الإقليمي للتحذير من العواصف الغبارية والرملية. 3. أكد المؤتمر على ضرورة إيجاد إطار تنسيقي بين الدول للتعامل مع العواصف الغبارية العابرة للحدود، ودعم جهود دول المصدر للتخفيف والحد من آثارها على الدول المتضررة، وإجراء الدراسات العلمية لتحديد مسببات حدوثها. 4. حث دول المنطقة على المزيد من التعاون لتمكين المركز الإقليمي للتحذير من العواصف الغبارية والرملية من تحقيق أهدافه التنسيقية والبحثية، وكذلك قيام الدول بالمزيد من الدراسات لتقييم آثار الغبار والعواصف الرملية على البيئة والصحة والاقتصاد للتقليل من آثارها. 5. التأكيد على أهمية بناء جسور التعاون بين المؤسسات البحثية الدولية والمراكز الإقليمية ذات الاختصاص بالتحذير من العواصف الغبارية والرملية في أوروبا وآسيا وأمريكا وأفريقيا. 6. الدعوة للاستفادة من مبادرات المملكة العربية السعودية الإقليمية متمثلة في المركز الإقليمي للتغير المناخي والبرنامج الإقليمي لاستمطار السحب والمركز الإقليمي للتحذير من العواصف الغبارية والرملية بما يحقق الفائدة للدول في الحد من الآثار السلبية للعواصف الغبارية. سابعاً، العمل على زيادة دراسات عن التداخلات بين الغبار والانبعاثات الناتجة عن النشاطات البشرية وتأثيرها على الصحة وعلاقتها بمعايير منظمة الصحة العالمية. ثامناً، حث دول الإقليم على إنشاء محطات بحثية متكاملة يتم تحديد عددها ومواقعها بشكل استراتيجي على مستوى الإقليم. تاسعاً، حث المنظمة العالمية للأرصاد على زيادة دعم المشاريع والبرامج المعنية برصد ومراقبة العواصف الغبارية في دول الإقليم، وخاصة الدول التي تعاني من نقص الإمكانيات. عاشراً، دعوة المركز الإقليمي للتحذير من العواصف الغبارية والرملية بالتعاون مع المنظمة العالمية للأرصاد والمؤسسات البحثية لإعداد دراسة أولية لإنشاء شبكة إقليمية لخدمة دول منطقة الشرق الأوسط تشمل إجراءات ومعايير رصد العواصف الغبارية بهدف تحسين جودة البيانات وسرعة تبادلها وتطوير آلية إقليمية للإنذار المبكر. 11، زيادة البرامج التوعوية والتثقيفية من الآثار الناجمة عن العواصف الغبارية والرملية على الجانب الاجتماعي والصحي والاقتصادي والتنموي. 12، تعزيز التنسيق في مجال بحوث الغبار بين دول المنطقة وعقد اللقاءات الدورية لتبادل المعرفة والخبرات في هذا الجانب. 13، رحب المؤتمر باستضافة المملكة العربية السعودية للدورة 16 لمؤتمر الأطراف في مكافحة التصحر والجفاف وارتباطه الوثيق بالجهود الرامية للحد من تأثير العواصف الغبارية والرملية. 14، دعا المؤتمر إلى زيادة البرامج التنموية الرامية للحد من الآثار السلبية للعواصف الغبارية والرملية على المجتمعات. 15، ربط مخرجات الأبحاث المعنية بالعواصف الغبارية والرملية لدعم سياسات صانعي القرار. أخيراً، الطلب من المملكة العربية السعودية الرفع بتوصيات المؤتمر إلى المنظمات الإقليمية والدولية المعنية في هذا المجال. أعلن في 6 مارس 24 العاصمة الرياض، المملكة العربية السعودية.
Thank you very much. And on behalf of the Scientific Committee, I would like to thank the Kingdom for hosting this landmark conference. And we are very much hopeful this will be the start of many more collaboration opportunities and coordination opportunities to find regional solutions to tackle this important challenge to our human health, our economy, and our well-being. The committee is pleased to recommend the outputs of this conference. As you have seen, and I hope the translation conveyed the messages, we have come up with a range of recommendations ranging from recommendations to establish regional networks to address the transboundary nature of this challenge, recommendations on establishing best practices for monitoring, for research, and more action-focused recommendations on conducting specific research on the interaction between natural dust and urbanization emissions and emissions from human activities on public health and how this feeds into the WHO guidelines, and more specific recommendations to the WMO and other UN organizations to support projects related to this challenge in the region with a specific focus on countries with limited resources. We would like you to reflect on the recommendations, and we invite you to make any comments, any clarifications, or any discussion points on any of the recommendations so we can endorse them at the end of this session. Thank you very much. I think we will open the floor for input or any questions or comments on the outputs before we declare them final. I think this is all in agreement. So thank you all very much. I'd like to thank all my colleagues in the scientific committee. I'd like to invite them for any contributions. If anyone has any comments. Okay, and thank you all very much. And we look forward to the next edition of this conference. Thank you.
Now, it gives me a great pleasure to invite His Excellency Dr. Ayman Ghulam to conclude the conference with his closing remarks. Dr. Ayman Ghulam, he's the CEO of the National Center for Meteorology and the supervisor of the Regional Center for Dust and Sandstorm.
بسم الله الرحمن الرحيم والصلاة والسلام على سيدنا محمد وآله وصحبه أجمعين. الإخوة والأخوات الخبراء والمختصين في العواصف الغبارية والرملية في جميع أنحاء العالم، أولاً أود أن أتقدم لكم بالشكر الجزيل على حضوركم لهذا المؤتمر، وكذلك أثمن مشاركاتكم القيمة والتي خرجت ولله الحمد بتوصيات ممتازة وتخدم إن شاء الله الإقليم وتخدم البحث العلمي في مجالات التصدي لمكافحة التغيرات المناخية، والتي واحدة منها العواصف الغبارية التي زادت في السنوات الأخيرة، سواء من ناحية العدد تكرارها أو شدتها، مع ظواهر جوية أخرى، ولكن تركيزنا في هذا المؤتمر كان على هذه الظاهرة العواصف الغبارية والرملية. أشكر مرة أخرى مشاركاتكم ومخرجات هذا المؤتمر التي سوف بإذن الله تعالى تخدم البحث العلمي وتخدم الجميع في التصدي لهذه الظاهرة. وأعلن اختتام المؤتمر الدولي الأول للعواصف الغبارية والرملية الذي يقيم في الرياض، والذي خرج منه إعلان الرياض. وشكرا لكم مرة أخرى، والسلام عليكم ورحمة الله وبركاته.
Now I'd like to ask all the official delegations and the speakers to come to the stage to take a photo group with the CEO and the organizing committee, scientific committee as well. So please to the stage. Okay, again, I would like to reiterate what I have said. Please, for the speakers, the invitees to come to the stage to have a photo group at the conclusion of the conference. So please do not hesitate, just come forward and be on the stage. Thank you, Dr. Ayman Ghulam, the CEO of the National Center for Meteorology and supervisor of the Regional Center for Dust and Sandstorms. Thank you for the organizing committee, scientific committee. Thank you for all the invitees for accepting the invitation, official delegations. Thank you for all the participants, for everyone who have participated in bringing this conference together and in bringing this conference into light. Thank you all very much until we meet, with Allah willing, next year for our next time for the sand and dust storm, the first scientific or the first international conference on sand and dust storm. Hopefully see you with Allah grace in the second conference. Wassalamu alaikum wa rahmatullahi wa barakatuh. I would like also to invite you for lunch. Lunches should be available at the 365 restaurant and the other restaurant. I would like to invite also the scientific committee for a photo group. Please, the scientific committee to the stage. All the members of the scientific committee, please come forward to the stage to have a photo group. And also the organizing committee of the conference as well. The organizing committee of the conference, please come forward for a photo group. Thank you all very much. والسلام عليكم ورحمة الله وبركاته. وعلى دروب الخير نلتقي. والآن ندعوكم لتناول طعام الغداء. We'd like to invite you for lunch. Please make your way because the restaurant is about to close. So please, if you can rush there. Thank you very much.